early as possible. Okay, so thank you, the Institute of Geology Career Research Center. Now the meeting is on the live streams. Okay, so
Okay.
now the meeting is start for the broadcastings. So I request our team, please send me the YouTube link on my WhatsApp, and you can send directly on the third international webinar WhatsApp group. Our team.
Yeah, of course, I will send it in 5 minutes.
Okay. Thank you very much. So okay, so okay, now the meeting is on the record. Its our team is clear. Our team?
Yeah, I'm here.
Okay, now the meeting is start for the recording.
Yes, the recording is started already. Yeah. I will send you a link and you will check it. Give me a second.
Okay, I think it is the live. Okay. Okay, thank you very much. You can also see the YouTube streaming. Now it is coming, the third international webinar on natural hazards and management.
Артем, у нас работает, да, все?
Да, все в порядке.
Is it working? You can check our team. Please check on the YouTube. Is it working? It is the delay by 3 minutes.
Я к тому, что да, что это не идет. Я к тому, что да, просто свернуть вообще будет. Да. Я к тому, что это проблема, здесь никого не будет. Я просто буду заходить, если мне прям кажется, что надо. А так я самое не буду.
Доктор Амутар?
Ну и вечером. Я сейчас переходим.
Yes, Dr. Rajiv Kumar Saxena. You want to say something? Dr. Rajiv Kumar Saxena? You want to say something? Maybe you put your hands, so then I thought. Okay. Okay, Professor Sergey.
Okay, I'm here. So we know when we start. You think we start after a few minutes, yeah? Not in time, not exactly in our time of program.
Okay, we have 5 minutes.
Okay.
Then maybe you finish your tea and then we will start. Professor Mukesh Pandey will join later on. He is in the meeting. He is in the meeting. So now he asked you should start the webinar and he will join when the meeting will finish as soon as possible.
Okay, Vinod, in this case, you can say a few welcome words and after I make our short presentation about our collaboration. So it depends how you think is better, okay?
Okay, just I give you some, and then the welcome address from the Vice Chancellor, he will join. Okay. Okay, so now the recording is going on well. Artem, it is okay?
Yeah, you can start if you want.
Yes, colleagues, we can start our conference, I hope. And
okay, so now I once again I welcome all of you, the delegates, researchers, and the other scientists who have joined here. Then due to the busy of this our Honorable Vice Chancellor, he will join later on. So I request Professor Sergey, Director, Institute of the Geologic, Karelian Research Center, Petrozavodsk, Russia. So I invite Professor Sergey to give some brief idea about how we have got the MOU between these two institutes, Bundelkhand University, Jhansi, and the Karelian Research Center, Petrozavodsk, and he will give you the some summary of our last two MOU and the next plan. Please, Sergey, please.
Yeah, okay, colleagues. I just try to share my screen. I hope you can see it.
Yeah, it works.
Okay. So I started. So dear colleagues, it's great honor to me to participate in the open ceremony to the joint webinar. And of course, it's great to me to see you in good health and in good spirit. So I like about this possibility to see my friends, Indian friends, in these webinars. So just a few words about highlights of our memorandum and about our job in the both about joint investigation of our organization. So our organization has a long history of cooperation, and I would like briefly introduce them. So Institute of Geology is a scientific organization, and it belongs to Russian Academy of Science, and actually geographically we're situated in the north part of Russia in the Karelia region. And main idea of our organization in this investigation, scientific investigation, actually we participate in the training of students on the basin of the Petrozavodsk State University. And actually we have a local program, postgraduate program for the PhD in our institute. And nowadays we have 9 divisions, and most of them it's a scientific laboratory, but we have analytical center, of course, and the GIS center. So it's a situation now. And of course, you well know the Bundelkhand University, Jhansi, and like us, the Bundelkhand University is education organization. So, and we train high quality specialists in geology. So it's very good, and I hope you well know our colleagues. So if we discussed about the cooperation, so they have a long history, it's more than 10 years ago we start, and the cooperation started just in 2009 when our colleagues visit the Precambrian conference in the Jansi, and we discussed about some joint work, and in 2011 we start first project about arcane crafted evolution of the Finno-Scandian and Indian shield, and it's very good start for our collaboration. So a little bit later in 2015 we signed the first memorandum of mutual cooperation between Bundelkhand University and Institute of Geology, and later on we worked together in many areas. So we join different field work in the different Precambrian sites, not only Eastern Finno-Scandia, not only in the Karelian and in India Cratons, and even the Lesser Himalayas. So this is a very good activity of our people. So at least in 2020, we signed the second memorandum of mutual cooperation between our organization, and it's very great for us that this memorandum have a few main topics which interesting for both organizations. So for us, it's quite important geology of commercial minerals and upland mineralogy and geoinformation technology and petrology, mineralogy, geochemistry, and isotope chemistry, and some our direction.
आकाश पता लगा?
И что, сейчас не слышно ничего, да? Okay. Okay, colleagues, we just try to check, to repeat my presentation. Could you help people from my institute just try to help me to show my presentation again? Okay. So it's surprised that now it's good. You can see something in the screen now. Colleagues.
Yes, we will see it now.
Okay. So I continue. So this is very good for our local press show about our cooperation and publish some articles about it. So, and of course the collaboration require resources. So our scientists involved in the cooperation are looking for some grants and write the project and then for national funds and some make some different activity. Yes, and I want to say something, a few words about the participants. Now, at least it's not only young people, and it's well-known scientists from both organizations participate in this collaboration, and at least more than 30 people recently involved in this cooperation now. So the project in progress is very important to say that our interest is focused in petrology and geology, Archean greenstone complex, and Bundelkhand and Karelian craton. And of course, this is a basis for geodynamic reconstruction of the early Earth history. And we study the mafic, ultramafic rarity intrusion, and some granitoids, and geochemistry and geodynamic system of polyproterozoic complexes of lesser Himalayan area, and make some comparison between the craton when Bundelkhand, Aravalli, and Drahval cratons in India. So the team at least for free last year we published more than 30 publications, and quite of them is a very high quality results. So here we talked about the main results of our team. Is the main idea could be some new ideas about Mesoneoarchean model for evolution of Bundelkhand craton. It's one of the great publication of our team, and of course a comparison between the Bundelkhand, Aravalli, and Drahval cratons and the position of all the structure in a canal and supercontinental structure and the supercontinental cycle. So of course, and the tectonism stratigraphy over Bundelkhand craton. So it's many results from different Precambrian geology scales. And of course, not only scientific results, it's our interest of our activities, many webinars and some conference. So at least now we make a third one conference with joint webinar with problems, but I hope the local press again make some focus to our activity. So of course we're looking for the future, and in future collaboration we have seen some trends, and it's not only fundamental geology, it's not only geodynamic and tectonics, but we're thinking about the natural hazards and management, about geotourism and geoinformation technology. And of course, we're looking for some new ideas in the organization, in the joint conference funding, and some interaction between the postgraduate and undergraduate students, because it's so very important. So I hope we have a future, and we have seen many ideas for all of us. So dear colleagues, in the final, I wish you a fruitful discussion and many new interesting ideas, and of course, health and prosperity. So best wishes from Karelia, and good job in this webinars. So thank you.
Thank you, Professor Sergei. So this is the idea to collaboration between the Bundelkhand Institute Jhansi and the Institute of Geology Karelia Research Center, Petrozavodsk. And this is our the fourth international webinar in this series. So last two on the natural hazards management, and one last year in February we completed the relationship between the Finnish-Canadian and the Indian cratons. And hope we will work continue later on too for this much more collaboration work and some such type of the activities. So these activities must be continued, we hope. Now I request Professor T.N. Singh. Professor T.N. Singh.
Please.
Okay, so I request you, sir, kindly give your talk on the rock mass stability. Professor T.N. Singh is the director of the IIT Patna. So please, Professor T.N. Singh ji, you unmute your voice first. Professor T.N. Singh.
Yes, yes, please.
Unmute your voice.
Yeah, are you able to hear me?
Yes, yes, we are able to hear you. And now you open your video to for the upload of this presentations.
Yeah, I'm uploading.
Okay.
Share करो presentation से. Desktop. Desktop.
And any problem, sir?
No problem. Just.
Oh, okay, sir.
Yes, sir. देखो इसको खोल दो ना, इसको ओपन करोगे तो चलो इसको शेयर करो। Are you able to hear my slides?
Yes, sir. Your voice is coming. We need your
No,
share screen.
slide I was.
Not yet.
Okay. So there is some problem in the just sharing the slide.
Can you send me your slide on my WhatsApp? I will open it.
Okay, just a moment.
Either you have the PDF file, then open it, sir, share it.
Yeah. So share करो. खुला है? नहीं कर
Yes. So it's okay, sir. Now it is coming.
Okay, thank you very much for giving me this opportunity to express my views on this related to the slope stability of weak rock, particularly in the eastern Himalayan region. You know, in this Himalaya, we have a very complex situation about this rock type, variability of this rock, the change in this geomorphological view, as well as the admixture of these boulders and the soils. Many a times we have a certain construction of this road as well as the embankment that gets damaged due to the various regions. There is a possibility of this sinking in this region. This is the area which is known as OKSRT road, which connects the Tawang, the border of the China. And on this way, there are the problems of the failure. Here you can see this, there is complete road is just sinking and going down towards the valley. And similarly, here you can see the completely shifting of that one. Here there is a larger cracks appear, and here again we have the localized some type of the tectonic cracks and other stuff. So the problems are of the different kinds with the different magnitude and at different regions also. This mechanics of this each failure is different from the others one. So it is not a replication of any kind of this idea failure to the other one. They are all unique and unique in the nature. So what we have done, we have tried to not only analyze this slope, but also try to how to improve the strength of the soil or soil-like slope to make it stable. And that is the reason what we have done. We have collected the sample as usual in the protocol has been followed. And we have tried to test this material because these materials are not this hard rock, as you can see on the slide. So we have prepared these samples. Before preparing the samples, we have tried to find out the size distribution. After the size distribution, there are certain geotechnical parameters which has been determined like the Attenborough limits. We have followed this protocol of ASTM D4318. And after that, these properties were determined. So we know the liquid limit, plastic limits, and the plasticity index of this material. Then we have gone for the other test, like the SPC, this is standard protocol compaction, that how it will be compacted and how this behavior of a change with the moisture content. So these are the properties which we have determined from this, and there are other various parameters. We have all this has been documented. So due to the paucity of the time, I'm not going to show you all the details, but these are these properties which we have used later on, and then you can see this consistency limit. Then what are the compaction characteristics and how the others are working on this. This is all a little bit mix of this geochemistry with this part. I'm not going to deal here. But then we have tried to find out some non-destructive testing like this ultrasonic wave velocity, so that we can know the dynamic properties of this rock and its relation with these various parameters. So what we have tried to do, because you know that lime is one of these ingredients which has been used since long, particularly in India, admixturing with these various other small components of the other material, and then we have tried to make it the compaction of that. So here we have tried to mix it in the various proportion of this, the lime with the existing soil, and try to find how these soils are behaving once they have the admixture of the various percentage of this lime, and then we have find that whether this kind of the treatment can be given on the site, because other techniques of the chemical injection, another is very, very costly affair. So these are techniques which has been used in the various modes and in the various places to just replace the weak soil with this treated soil, I can say, and this ground improvement has been achieved. These are due to this, you can say, when started, not in the new things we have done, but we have tried in this area in the first time. And you know, this plastic deformation and the plasticity index has been changed due to the cation exchange reactions, and the particle size has been also changed due to this kind of combination of the problem, this one. And then the sustain parameters we have determined. So after that we have the strength parameters. So uniaxial compressive strength has been determined. The samples are made as per the strength size, and they have been tested with respect to the time. So you can see the behavior of material with the percentage of lime content to the uniaxial compressive strength of the rock. And we have started with this lime content 1%, 2%, and gone up to the 9%. What was the purpose of this doing it? To optimize the percentage of the lime which should be mixed, and so that we can get the maximum strength within this packed material. And here you can see this 5% is considered to 5 to 7%, or at maximum 5% we get the maximum gain, and that is the region in all, irrespective of this, you can say this stage. So this will be the optimization that, okay, we can make it in the 5% of the lime under the mixing. And just you can see this will be highest improvement was observed. Now this modulus of elasticity, which is one of the important parameters, that also we have determined in the same manner as in this earlier, this UCS for the days versus the time, as well as the lime content. And here also we have found that the 5% lime mixing within this rock will give you some improvement, and it is a consistent one. Then after that, very important parameter which will be used in this slope stability, the shear strength parameter of this material. So the shear strength has been determined of the same material with a variation in the lime content, and we have tried to find out what should be the optimum shear strength gain. And again, this 5% will be giving the maximum gain. So just cross-check all these methods by using this checks and balance that yes, 5% is the optimum for all the parameters having the increasing trend and the consistency in this with respect to days. So that will be the thing which we have done, and this is the completely all the data has been put into this one place with doing certain statistical analysis about it, and this you can see that the mean and median has been taken, the maximum and minimum parameters has been taken, and then we have the some stress component analysis also. So you can see here, these are the variations. Then we have tried to find out the interrelation with this one parameter, the other parameter. Then these are this relation which has been shown. And some of them are having the correlation is appreciable, but some of them having a very, very poor correlation. So that should be ignored. And there is a lot of variability in the data set. Likewise, you can see this other, the cohesions, then phi value. Then you have this, what will be the measured cohesion versus the predicted cohesion, how they are interrelated. Some of the parameters are good correlated with this measured one and the predicted one, and having a very high correlation coefficient. So these are the parameters which are given. Then we have used this adaptive neurofuzzy interface system to give this input what we have observed, and we have tried to find out this, you can say, this unknown values of the C and the UCS1. The purpose is doing to try to see that if you have this unknown area and you have a certain geotechnical parameter, then whether we can go ahead with the using this AI tools. Then somebody can use this different tool also, but we have used this mixed mode of the scientist model, artificial neural and the fuzzy logic together, and then we have tried to find out the results. And here also you can see that there is a consistently improvement of the correlation coefficient that we have found. And then you can see whatever these parameters we have used, we have made some comparison with it. That will be the performance we have found. That multilinear regression analysis, then using the artificial neural and NFIS, which one will be giving a better result, that we try to find out. All these are three important parameters for this UCS, this elastic constant, and the cohesion and the phi value that has been taken into account, because these are the parameters that really control the stability of any of the slope. So just you can see this comparison. Now I'm coming to this actual field from where we have selected these three sites. And these will be site 1, site 2, and site 3. This is a Google Earth picture. And you can say this geologically, these are this area where we are, and these are this variability of the rock type. These are from literature we have taken. So just you can see this, all the three slopes we have taken into account. Just you can see this here. And we have, you have tried to create the similar kind of this physical behavior or physical appearance as it looks here, because this is the area, the another slope, and this is the downhill slope, and it is going to the valley. So we have a different steps like things. Here also you can see this profiling, and this another one you have this profile. So all the three have this variability in terms of the slope geometry, where the height and the width of this material and the material characteristic thickness will be changing with the time and the space both. Now you can see these parameters for this one, how to stabilize it, and then what this result we get it. So we have analyzed this slope behavior with this without this seismic parameter and with this seismic parameter, because this area is known as the seismically very high sensitive zone. So these are the results. You can see these results indicate that without seismic activity, these are the factor of safety which you can see, and these are the zone. So most of the places we have the slopes are looking stable, and the same material of the 5% has been added to this material property, so that we can see the improvement, and you can see the improvement after this 180 days of the curing time. Similarly, you can see here that is once you have the seismic activity, so there is a consistently, or you can say this very dynamically improvement in the factor of safety once you are making this line based this stabilized technique, and we have crossed 1.5 or 1.6 the factor of safety to the 2 under the dynamic zone. Again, without seismic zone, you can a different, this is slope 2, where this 3 days and 7 days curing time, and you have a different factor of safety. Just you can see this how the factor of safety has been increased once you can mix with this treatment what we have designed. And this is the another slope where we have the seismicity. So this is the third slope, which you remember that the high one very big slope or high slope because the height is more. So just you can see this factor of safety, then we have the curing time, then we have this seismic activity where the slope is under the danger because the factor of safety is less than 1. Here also it is just slightly high, so likely to be failure. So these are the things we have done, and this compare both the condition about this seismic and non-seismic, and you can see the lower factor of safety always gives us the failure conditions. But as the curing time is increasing, the lime is giving a good result, and there is a consistency about this. Once it is passing the 40 days of the curing time, and then there is a certain reaction level or time is completed, and then the slope has shown, that material has shown a very good performance and improvement there, their strength and the stability. So at the given time, what will be the outcome of this? That the 5% lime will be the right thing to mix with this given soil slope, and then we can see there is a change in this geotechnical parameter after the 28 days of putting into certain water or keeping the moisture, optimum moisture with the soil. So that will be the one. UCS has been increased, and similarly all the other properties like elastic constant and the tensile strength, the shear strength, even the cohesion, that has been also increased substantially to support the slope in the right manner. Then we have tried to do this kind of this, you can say this mathematical analysis about this, the regression approach, and these are some of the equations which is very complex in nature while using it, but we have just established that one. And then we have used a various type of the numerical methods and this, you can say the artificial neural network to verify our result and see the consistency of this result, so that we can, at least we can advocate this idea which we have taken into account. And then finally the slope stability analysis of the 3 sides, where this without seismicity and with the seismicity, means the static and dynamic slope has been analyzed. Without mixing the 5% lime and then mixing the lime, and we have found that the mixing of the lime is giving a very, very good result, and even the unstable slopes are becoming a more reliable, more stable, and more consistent with respect to the time. So this is all about my presentation within the given time, and hope I have not crossed the time boundary given by Professor Binod. Thank you very much.
Thank you, Professor Singh. It was a very nice talk. And any questions from the audience, please?
Yeah, I have.
Yeah, please.
Namaskar, sir. It was an excellent lecture, and some new thing I came to know about this thing. I have one query, or I generally get problem that my question is on from the rock slope stability. Generally, we don't get the C5 and rock testing is not possible every time. So always, how good it is to use those C5 from the already available literature or from GSI. What is your suggestion?
Yeah, I think it is a very, very practical problem, and almost everybody's mind, this kind of questions are just bugging those who are particularly working on the slope stability. Because the realistically to determine all the properties is time consuming, availability of the equipment, and the expertise to understand the data in the real sense. Once you don't have these parameters, means the actual parameters, of course you have to take from the GSI, that will be taken into the consideration. But better to adopt at least minimum 2 to 3 other back propagation methods to just verify the results. Because if you can dependent on one, maybe we have a jaundice eye about this problem. So better to avoid these things, we have to have a 2 to 3 types of the cross check. Once you can use the JRC in this rock type. Another, the strength reduction technique can be taken into account while analyzing the slope. And third thing is, I think that will come, it has no any instrument but the experience and expertise of the person, which plays a very, very significant role, because those who are hitting their head with this rock from last many, many decades, they have a better understanding while looking through this rock. So these are the 3 approach one can adopt if no data is available. I think somebody else has also some question.
Thank you, sir. Thank you.
Thank you. Professor Ramavatar, I think Professor Ramavatar having some question.
No, sir. I have no questions.
You are raising your hand. And I think some of the young fellows having some questions definitely in their mind. Those who are little bit new in this working, Professor Sarkar is have the wide experience and a very, very renowned person in the field of this slope stability and landslide. But any young faculty members or research scholar, you have any question? So,
okay, any
anyway,
more
there
questions?
are many known faces, but
anyway, no more questions from any young scholars. Professor Nageshwar Dubey, do you want to any questions? Ask any questions? Your voice is...
Unmute, please. Unmute. First unmute Professor Dubey.
Unmute your voice.
Just to convey my regards and namaste.
Okay, thank you very much. Namaste.
So, okay, sir. So, should we proceed for the next lecture?
Yeah, thank you very much.
Okay. Okay, thank you, sir, Professor T. Singh ji. So,
Thank you.
now, probably, Professor C.S. Dubey, he is not. Have you seen Professor C.S. Dubey? I call him on the phone, but he didn't get my voice. Professor Dubey, Chandrasekhar Dubey, he is not here, I think. Then maybe we call to the Professor Dhrusen Singh. Hello, Professor Dubey is here. Okay. So now I think we should first call to Professor Dhrusen Singh. Then the CS Dubey will join. I think might be some problem with the CS Dubey. Professor Dhrusen Singh, please unmute your voice. Where is Professor Dhrusen Singh? Maybe some problem with Dhrusen Singh too. सर अनम्यूट कीजिए अपना वॉइस. ओके सर, अनम्यूट करके बोलिए सर. हेलो प्रोफेसर धृषण सिंह, आपकी आवाज नहीं आ रही है. प्लीज अनम्यूट योर वॉइस. Hello. What is the problem? Why you could not see the where he joined? Mr. Dhrusen told me that he had joined, but I could not see his name.
Hello.
Yes. Okay. So
Yeah.
iPhone. Okay. Okay, sir. Most welcome, Professor Dhrusen Singh from Lucknow University. So now I request Professor Dhrusen Singh, please give your talk on the impact of climate change on society. Please, Dhrusen Singh.
Yeah. Good afternoon. First of all, I would like to express my sincere thanks to the organizers of this very valuable interaction and the conference workshop, and providing me an opportunity to interact with the learned participants and the delegates. The topic assigned to me, that is the climate change and its impact on society. I am really very sorry that I am not presenting in a very formal way, because I am engaged somewhere else, but it is only because of the organizing committee, especially to Professor V.K. Singh and Professor Ramotar, that I accepted their request to deliver this talk. So sorry for not being very formal. But we all know about the climate, that the climate is changing and it keeps on changing. The scientific records for the changing climate are abundantly clear. We know that it will change. Certainly it will change. but how it will change and at what rate it will change and how it is going to affect the society is yet to be known. And that is why scientists, not only from the geology background, but from different disciplines, from all parts of the globe, they are trying their best to find out that what is the rate of climate change and how it is going to affect the society. Dear friends, we all know that environment is a very big term. And different components of the environment, the hydrosphere, lithosphere, and the atmosphere, they are providing very important aspects for the survival of life on this planet Earth. The hydrosphere is providing free of cost the water we drink. The atmosphere is providing free of cost the air we breathe. And the lithosphere is providing free of cost the soil on which we are cultivating our food grains. So environment and different components of the environment, the hydrosphere, lithosphere, and atmosphere, they are providing the life support system. But these different components of the environment, they are being degraded by the anthropogenic activity. They are being polluted by the anthropogenic activity. And at the same time, the climate change is also affecting all these things. So there are two things. Number one, the natural aspect, and number two, the anthropogenic aspect. We all know that the climate is changing, but there are evidences, geological evidences, that the climate had changed many times in the geological past, even before the evolution of man on this planet Earth. But when man appeared during Pleistocene period, and when man started a number of anthropogenic activities, especially after the Industrial Revolution, when man started polluting the different components of the environment, then we were forced to believe that there are two things which are affecting the climate. There are two things which are affecting the environment. Number one is natural factor and second is anthropogenic factor. So now it is very difficult to delineate a boundary that how much climate change is natural and how much climate change is anthropogenic. We know that after its appearance, man is also affecting and controlling the climate change, the environmental change, the natural change. The man is accelerating, the man is affecting either positively or negatively, but man is also affecting the climate change, the rate of climate change. So if you just look that each and everything in the climatic system, each and everything in the environmental system, each and everything in the natural system are in equilibrium. If we are adding anything to this equilibrium system, or if we are depleting anything to this equilibrium system, that leads to the disbalance, and that causes the hazards, that causes the disasters. It means all the natural systems are in equilibrium. They are not going to create any hazard. But if we are adding anything to that balanced system, such as we are continuously adding carbon dioxide to the atmosphere, or if we are depleting anything from that natural system, such as we are continuously depleting ozone from the natural system, which creates the disbalance, that is the hazard, that is the disaster. So I personally believe, and we all know, that there is no term like natural disaster. Everything is natural event, whether it earthquake, whether it volcano, whether it landslide, flood, drought, cyclone, tsunami. Each and everything are natural events. And they had happened, they had affected this globe even before the appearance of man. But now what is going on? That man has interacted into the natural cycle of the earthquake. Man has entered into the natural cycle of flood. Man has entered into the natural cycle of the river, tsunami, landslide. And when man has entered into the natural cycle of every natural event, man is being affected by those natural events. No, and if loss of life and property takes place because of that natural events, that becomes disaster. So all the events, if man is not going to be affected by those natural events, either by tsunami or earthquake or landslide or flood or drought or cyclone. They are the natural events. But if loss of life and property takes place, then that natural events become disasters. It means it is very important that how man is interacting with the natural events. It is very important that how we have planned, how we have settled, how we have planned a goal that how to live with these natural events, how to minimize the damage done by all these natural events. So there are only two things through which we can minimize the damage done by all these natural events. Number one, we should follow the law of nature. And second, we should follow the scientific facts, because natural events are natural. And nature is that part of the environment which is beyond the control of man. We cannot control the natural disasters. We cannot control the natural hazards. We cannot control the natural events. Why? Because they are natural. And nature is that part of the environment which is beyond the control of man. It means by following the law of nature and by following these scientific facts, we can only minimize the damage done by all these natural events. So there are the only management for natural hazard, the only management for natural disaster is to follow the law of nature and the scientific facts. If you just look at the impact of climate change in society, then we are forced to believe that because of the climate change, in the last few decades, we can see or we observe that the frequency of natural hazard, natural disaster has increased. Is it really true that the climate change has increased the frequency of natural hazard? Or there is something else? I believe that the frequency of natural hazard, natural event is same as it was in the past. But nowadays we have entered into the, for example, in 2013, a Kedarnath tragedy took place. We witnessed so many loss of life and property. We cannot forget that event. But as a Himalayan geologist, we all know that cloudburst is a frequent phenomena in a Himalayan region, which took place every year in one or the other part of the Himalaya. But until and unless loss of life and property took place, that is a cloudburst only, that is a natural event only. But if loss of life and property took place because of that cloudburst, then that becomes the tragedy, then that becomes the disaster, then that becomes the hazards. It means we have entered into the natural cycle of the cloudburst also. Earlier, the people, they were living away from the zone of all the natural events. The people, they were living away from the peril zone of the flood, peril zone of the tsunami, peril zone of the earthquake, peril zone of the landslide, peril zone of the cloudburst, and so they were rarely affected by all these natural events. But dear friends, we all know that in India, there is only 2.4% of the world's total land, where 17% of the world's total population is living. We know that this is the peril zone. We know that this is the flood-prone zone. We know that this is a tsunami-prone, landslide-prone, or cyclone-prone zone. But we are forced to live into that peril zone because there is tremendous pressure of population on land. And due to this increase in population, tremendous pressure of population on land, we have narrowed the valley of the river. We have constructed the artificial levee on both sides of the river. Earlier, the valley of a river, the channel of a river was about 2 kilometers, 10 kilometers, 15 kilometers. There are so many rivers in Ganga plain which are having 20 kilometers of the valley of the river. Their water can spread in 20 kilometers. But because of the pressure of population on land, we have narrowed that channel into 300 meters, 400 meters, 500 meters, 600 meters. without analyzing the discharge of the river. Now that narrow channel is not capable of accommodating the maximum discharge of the river. During monsoon, when water increases in the river, that may overtop its banks and causes the flood in the nearby area. That is not very dangerous. Why? Because the river water has overtopped the artificial levee and has caused the flood in the neighboring areas. But if the water of the river increases, and if that water breaks the artificial levee, then that is devastating. Because we have constructed the artificial levee without analyzing the discharge of the river, the narrowed valley is not capable of accommodating the maximum discharge. Because of the increase in the pressure within the channel, the artificial levee may break at a number of points. For example, in the Rapti River, in Gorakhpur, in Uttar Pradesh in 1998, the levee was break. And because of the break in the river, devastating flood took place, which have washed out each and everything in the nearby areas, which deposited 1 to 2 meters of sand in the nearby areas, which washed out completely not only the petrol pump, but the petrol tank lying below the surface of the earth. Just imagine about the devastating flood of the Rapti River of 1998, which was not natural event, which was anthropogenic, artificial, because we narrowed down the valley of the Rapti River by constructing artificial levee on both the banks. The same situation took place in Kedarnath also. Because due to climate change, when the discharge of the Mandakini River and the adjoining Saraswati River decreases, we constructed the settlement in the valley of the river. We enclosed the valley of the Mandakini River partially, and we completely enclosed the valley of the Saraswati River. As a result, there was no place at all for the flow of water. There was no place at all for the flood water. There was no place for the natural flow of the water in the Mandakini River and the Saraswati River. That was obstructed by the construction made by us in last few decades. And that's why when rain took place, because of the southwest monsoon as well as northwest monsoon, on 13th, 14th, 15th, and 16th of June 2013, the precipitation was very, very high, because precipitation was taking place by both the monsoons simultaneously, the winter as well as the summer. It will be better to say not winter and summer, but the southwest and the northeast. The southwest monsoon and the westerlies are the western disturbances. So the precipitation was much more higher than the normal precipitation in the Kedarnath region. And due to this precipitation, at a number of places, landslides were initiated. These landslides, they blocked the Mandakini River at a number of places. Because of the blocking of the Mandakini River at a number of places, the artificial lakes were formed. The water was rising in the Mandakini River. Number one, changes which took place because of the abnormal and heavy precipitation in the Kedarnath region. Number one, changes which took place was the rise of water in the Mandakini River. Number two, a number of new channels were initiated. Number three, abundant channels were activated. Died rivers, they activated because they get the water. Number three, because of the landslide, a number of artificial ephemeral lakes were formed in the Mandakini River. And number five, the Chaurawari Lake or the Gandhi Sarovar was completely filled. Because of all these changes, the artificial and the natural lake, Gandhi Sarovar and the Chaurawari Lake, they bursted And because of this bursting, because of the rapid flow of the water, because of the devastating effect of the water, each and everything was washed out in the Kedarnath region. This is the impact of climate change on the natural hazard. Because of the climate change, the water decreases in the Mandakini and the adjoining Saraswati river, and the people, they completely occupied the channel of the Mandakini and adjoining river without leaving the space for the normal flow of the river. So due to when heavy rain took place, there was no place at all for the flow of normal water. And because of the obstruction, because of the bursting of the lakes, each and everything was washed out in the Kedarnath region. So what is going on? That climate change is a natural process. No doubt, the anthropogenic activities, they are enhancing, they are accelerating the change of climate change. But it has changed many times even before the existence of man on this planet Earth. But the pollution, the changes which are taking place, the unwanted changes which are taking place in the environmental components, such as hydrosphere, lithosphere, and atmosphere, known as pollution. The pollution is 100% anthropogenic. Pollution is not natural. If we are changing any unwanted change in the hydrosphere, lithosphere, or atmosphere, that is pollution. And this pollution is 100% anthropogenic. And we all are trying to sustain, to conserve, not to change the climate change. I personally believe that we should try not to pollute the different components of the environment, which are 100% anthropogenic in nature. So climate change is natural, but the pollution is anthropogenic. Climate change has taken place many times even on this planet Earth, even before the appearance of man on this planet Earth. But the pollution means addition and depletion of anything in the hydrosphere, in the lithosphere, and in the atmosphere is anthropogenic, is man-made only. Dear friends, at present, we are using treated water. We cannot take untreated water. At a number of places, we are using the soil also, treated soil, means we are using fertilizer. Means we cannot use the untreated hydrosphere and we cannot use the untreated lithosphere. Atmosphere is the only component of the environment. Atmosphere is the only component of the nature which is being used for the survival of life on this planet Earth in an untreated way. And therefore, it is our moral responsibility to think for the conservation of all these natural resources. Otherwise, in the days to come, we cannot use the atmosphere untreated also. Therefore, anthropogenic activities should be done in such a way so that we can develop in a sustainable manner. And that's why this new term, sustainable development, was coined in 1990. Because every developmental activity is done at the cost of environmental degradation. And therefore, it is our moral responsibility to develop in a sustainable way. Dear friends, the natural events are natural. They cannot be controlled by man. But by following the law of nature and scientific facts, we can minimize the damage done by all these natural events. Therefore, by this time, we should try to live with the natural events so that we can enjoy these natural events, as they cannot be called as natural disasters. The natural events are called natural disasters only when the loss of life and property takes place. Therefore, through this conference, I would like to request everyone that come forward to save this planet Earth and to develop in a sustainable way so that we can hand over our coming generation a neat, clean, and green Earth, and so that we can conserve all components of the environment in such a way so that we can, the nature which is providing free of cost all the basic services without which we can't survive on this planet Earth, without which we can't sustain on this planet Earth, whether it hydrosphere, lithosphere, or atmosphere. Therefore, it is our moral responsibility to think for the conservation of these natural resources so that we can hand over our coming generation neat, clean, and greener. Thank you. If there is any query or any question, I will be very happy to answer all those questions. Yeah, thank you. Over to you, Professor V.K. Singh and Professor Ramotar ji.
Okay, thank you, Professor Dhruv Singh. So it was a very nice talk. Any questions, please, from the audience? Nageswar Dubey.
Actually, it is not a question. First of all, I would like to congratulate him for a very nice and basic contribution, because as a geologist, we know the history of the earth and how nicely he has correlated that such events have taken place many times in the history of the earth.
Yeah.
So I would like to thank Professor Singh to warn the society to behave within the limits of the anthropology, because people, they are crossing the limit and the consequences, they are not good for the society. So thank you, Professor Singh.
Yeah, thank you. Nice to see you after a long gap. And it is our moral duty to sensitize the people of the society, because we know much better about all the natural events and the natural disaster than anyone else.
Professor Rahul Verma. Rahul Verma, please.
Yes, sir.
Unmute.
Yes.
You want any queries, questions?
Yeah. So nice to see Professor Dhruv Singh after a long time.
Yeah.
And your very informative speech. It reminds me of certain aspects of over flooding in Brahmaputra River. You can blame it to the tertiary orogeny. So that is what is my observation, because all the tributary rivers of Brahmaputra are carrying a lot of load into the Brahmaputra basin, and we read the old story, Kaua laya kankad, pani aya upar. So that is the reason. Flooding in Brahmaputra. Anyway, thank you, sir.
Okay, Professor Rahul, nice to see you after a long gap.
Yes, you should.
Yeah.
Okay. Any question from the audience? Any questions, please? Anyone? Okay, so I think once again, thank you to Professor Dhruv Singh.
Thank you, Professor V.K. Singh. Thank you.
So now, Professor Chandrasekhar Dubey, CS Dubey, just unmute your voice. Professor Dubey, yes, okay. Please unmute your voice. And okay, thank you, Professor CS Dubey, Vice Chancellor of the K.R. Mangalam University, Gurgaon, Haryana. So now his talk is the review on the natural hazards and the tectonic map of India. Please.
Can you hear me?
Yes.
Hello.
Okay. Yes. Orographic and tectogeographic content.
This is
controls. Okay.
Yeah, actually, I just want to show. I have listened to the earlier talk, and I have many publications and PhDs on hazards and natural hazards, and especially related to the man-made disasters as well as the geogenic disasters on arsenic, and as well as on the Uttarakhand and the Sikkim and the whole Himalayas. This work, I just want to put a few things that where from and how the hazards are coming, in the system, in the Himalayas, and what are the actual main, problems, how it develops, and how the extreme events are reported, and how the system changes, as you were saying, due to the climate change or due to the heavy rainfall,
how the whole system of the hazards occurs. So this study is one of my student study, which is basically on the Garhwal Himalayas. I don't want to go to the details of this, but you know what we have done here is that we have tried to find out the relationship of the erosion rates with orographic precipitation and tectonic activity in the basin, which was being discussed previously by the previous speaker. And the anomalous erosion rates in the two basins and its relation, it actually happens everywhere. If I show you the other diagram, can you hold for a moment, please? Just for a moment, please. Yeah, I will show you in the next few slides. So this is, can you see this slide as well? Hello?
Yes, sir. What you want to say, sir?
नहीं, आपको मेरे ये slide दिख रहा है?
Number three slide is we are able to see. Go to the next slide.
ये दिख रही है? नहीं.
No,
जी
no.
हाँ, जी हाँ,
Number...
दिख तो रही है स्टेटमेंट ऑफ प्रॉब्लम.
हाँ, ये चलिए मैं इसको शुरू करता हूँ, फिर मैं आगे दोबारा रिलाइन कर लूंगा. What I want to show is that how orographic precipitation is related to the erosion rates and the extreme events, you know. So what we have done is we have developed a morphotectonic map of the most highly tectonic activity in the area in the Garhwal. And we tried to estimate and compare the spatial temporal relationship of erosion rates with the Garhwal Himalaya in relation to tectonics and climate. And we have mapped major extreme events. I will show you the diagrams. This is how the methodology was taken over. We have taken the TRM transmission radar rainfall mode mission data, but now we take generally CHSR data and digital elevation. We have tried to put down where are the orographic barriers. With the morphotectonic activity, we have tried to map the erosion rates, and then we have collected the data of discharge and sediment load and looked at how it is occurring, the hazard zonation. We have tried to do some kind of hazard zonation over here. So in this one, you can see that actually you see this is the diagram made from Shlidia, Ray, and Shukla, others. There is a paper published by us in 2013 on the Kedarnath disaster and 2014 on this in the natural hazards. So you can see the structural features of the geology and structure of the Garhwal Himalaya. And you can see the catchment area drainage. You can see the basically the morphotectonic map of the study area. We have divided into certain basins and tried to see that where we have the, based on the drainage orders and based on the all these morphometric parameters like RB, R1, DI, and RF, RA, VF, etc. We have tried to identify which are the highly active regions and try to see that very high regions are actually in the lower vicinity of the near the below the MCT, and there are, you know, you can see the thrusts, you know, which are here like the Vakrata, the main central, the Ramgarh thrust, and the main boundary thrust. Now you see here we have tried to see the valley, the relation between the valley floor width with the thrust zones, and you can see that in here we can see that with the VF we can see that MCT1 is the most very active zone, and some part of the MCT, some part of the MCT3 is active, but that north Almora thrust is also very active. And you can see wherever you have, this is 0.001 or less, it is very highly active. So very highly active is where is less than 1, or 0.01 to 0.05, 0.5 even is very. So almost all these areas are very highly active for the disasters based on the tectonics. And you can see the areas which are where actually the regions where the most active portions occurs. So we tried to relate it with the VF values, and we could see that the thrust areas some of the areas are very highly tectonic. You can see the yellow spots, which are very, very high and active zones, and they are mainly near the either roads or the river. It is close to the river. Let's go back to the, so this is the morphotectonic active area map, which we prepared through this. And you can see the very highly active zones are basically near the Pithoragarh, as well as somewhere in Uttarkashi, Bhiwadi area, because of the earthquake. You can see also occurred here and here at some times. And then there are some places close to, even it is not marked here, but there are some places, see this Kedarnath is also very highly active these regions. So, and this is the rainfall, the precipitation pattern from 1974 to 2010. It still exists in the same way. And the TRMM precipitation we have taken from, the rainfall precipitation we have taken from 1998 to 2013 in the studies. And you can see the general pattern is same, that most of the highest rainfall occurs in these regions. Where are these areas? So you can see blue, it is very, very high rainfall which occurs in these regions. And these are all below this main central thrust area, MCT1 area. These are below main central thrust, and above, you can say, basically the North Almora thrust zone. But here it is maximum, it is at this circle and at this circle. You can see that there are correlations between orography and precipitation as well as the tectonics. So the rainfall is occurring high in these portions below the MCT. So MCT acts as a barrier. And when it acts as a barrier, you can see here we have made a map of showing how it acts as a barrier. So you can see the area, you can see the heights, you can see the lesser Himalayas and areas. And you can see as you go up to the lesser Himalayan sides, the rainfall increases, the TRMM monsoon precipitation in days, it shows increase. And it is from 1992. So there is definitely a relation between tectonics. Right from the higher Himalaya, the rainfall is less, as we know in the STDS, Tibet zone, there is very less rainfall. But as it moves towards the thrust areas, especially lesser Himalayan areas, the rainfall increases. And this is because of the barrier which comes around in this area near the MCT2, which is a barrier. And you can see at this point, above this, you have a high rainfall. On this side, you have a less rainfall. Similarly, this is another along Bhagirathi River, showing the same kind of a relationship. And you can see here that what we did, we collected these, we requested CWC to give us the data of these areas for the annual average discharge in cubic meter per second. And we tried to relate this as well to the erosions and the tectonic activity. And looking at this, you can see here that elevations have been shown, and again the thrusts have been marked very nicely over here. The sediment load data has been given here from 74. We had something like 8 to 9 stations where we have data of either annual average discharge cubic per meter and annual average sediment load tons in 10 to the power 6. So this is where we had this data, and based on this we tried to see where are the extreme events. So huge data, and we looked into, we saw a lot of data, taken a lot of data with their references, and we tried to see where these occur. And you can see there is a definite relation from the location, Badrinath, Joshimath, Alaknanda Valley, Alaknanda, Ganga Valley. All these earthquakes, you can see the periods, you can see the rainfalls, you can see the discharge, you can see the types of events, you can see vulnerable effects. If you go ahead, you can see the whole data. And this is some of the data. We calculate actually much more data than this. And we try to see where actually what is the relation of discharge with the precipitation. And you can see that there is a somehow it is correlatable, like here, it is correlatable, here it is correlatable, and here it is correlatable. So we had some relations over here. And in the so extreme events correlated with the sediment load discharge at Rudraprayag. You can see the sediment load discharge, and we have shown the, different landslides and, rainfall, cloud bursts, which are happened over here. And you can see they have a definite relation with the kind of a blue line and the red line are quite correlatable, the discharge and sediment load. And here, due to the heavy discharge and heavy sediment load, you had a lot of actions which have taken place. And you see the most of them are close to the thrust zones. Similarly, in the Uttarkashi zone, we have made this diagram and see quite correlatable. Similarly, we have put it in the Tehri area along the Bhagirathi, and this is the Devprayag. And we calculated the sediment yield and erosion rate of all the areas. And what we found that here, the calculation that with the drainage area, both the river at Devprayag station estimated to be 686 tons per kilometer per year, and at the rate of 2.59 millimeter per year. And this was given by Chakrapani, but we saw a little higher than this. The Alaknanda Bhagi River basins, Maneri estimated to be 863 tons kilometer per year, 3.25 millimeter per year. And you can see it is little higher, much higher than what was expected in both the areas. Probably he has taken for 3 years, and we have taken a bigger data to show our results. So again, these are the river discharge in different places, and the tons. So it's a very high amount of erosion has taken place, and silt yield has taken place in these areas. We have checked the annual erosion rates. They are also compared to these areas mostly. And then we put the landslides and the other things in these areas. And you can see most of the landslides are in near the orographic and below the main central thrust area. So this is the orographic barrier, and most of the landslides occurs in these areas. And a very few landslides occur in this area. So out of the 308 landslides, 109 occurred in the morphotectonically high active zone. This zone also has 20 out of 18 instances of landslide occurrences. Moreover, most of the landslides occur below MCT and the area of high precipitation. So you see there is a definite relationship, the orography, the higher precipitation, and the tectonism, as well as the extreme events occurring in the area. So this is quite a good relationship you can see here in the 3 spots. And these are very interesting areas, So our conclusion was that basically, if we took the data from the 1978, 98, 2005, and 2010 and 11, the water discharge and sediment load data in the study area was high, which could be due to intense monsoon rainfall and melting of the glaciers. Valley floor width, because these periods were actually warmer periods, much warmer periods. And in 2005, 1998, the temperature anomaly was much higher than what it was in the average periods. So this has completely closely a relationship between the, a relationship of the discharge and sediment load. But when we see orography, it is quite nicely related with the orography and tectonism, and then further with the orography and tectonism, which we can see with the valley floor MCT zone tectonically active areas. Most of the things lie that there is a relationship between the tectonics, orography, orographic barriers, sediment discharge, and the water discharge and the sediment load. So this very clearly shows that the climate of change as well as the tectonics show a very, very good relation to each other. Now, coming back to another slides, I will just change this from this to another one. This is another work which was done by us, in this area. Same kind of work, but we try to correlate Sikkim as well. And again, the things were, can you see this slide, please? Can you see this slide? Hello?
I think not
Hello?
yet. Not yet.
You can see this?
Maybe others can see.
No. No, no,
Okay,
no.
just please hold the line. No problem. I have to go to share screen. To find where it is.
Yes.
So this is another work of another my student in the same direction. But what we did is we tried to correlate the extreme events, the towards the eastern side or the central eastern side and as well as the western side. And on the same patterns, we tried to identify the things. You can see the areas. You can see we tried to find out what is the role of erosion with respect to geology, tectonic and precipitation. Is there a mechanism of among exhumation, uplift, tectonics, erosion and precipitation in the lesser Himalaya? What are the effective geomorphological parameters on erosion and sediment yield? And which model is the best quantitative estimation of amount of erosion in the lesser Himalaya? Which calibrated model is compatible with these conditions? Now, these were some of the things we try to find out. And our study area had large, again, annual runoff variation. It has a high sediment flux, peak discharge events. And you can see this, because again, we have chosen these areas because they are certainly different from others. Again, the same kind of, almost same kind of thing, but here we did something from not with the discharge, but more of with the exhumation rates and the erosion rates and different present day models. And we tried again the same way, both the Sikkim and the Garhwal Himalayas, and we made all kind of diagrams. You can see here aspect map, morphometric factors. We took again the almost same kind of morphometric factors, and you can see we tried to again identify through VF that which areas are active, and we could see that these areas 0.06 and 0.35, 0.27, they are very active areas. This area is very, very active areas, and so as the VF we can see over here. You can see the purple colored dots, which are points of very active VF. Similarly, we have already done this in the Garhwal Himalayas. And while comparing, and you can see here that we took all the average incision rates, which is about approximately 1.97 millimeter per year and 2 millimeter per year in Alaknanda River catchment and Bhagirathi. And the incision rate in Garhwal Himalayas was 0.62. We did all these samples, we put all these dates in one place, and we tried to correlate them based on and try to find the erosion and exhumation rates to this. So our study depended here on the low demand data, ease of use, easier parameter estimations, remote sensing mainly, and potential for improvements in the models of the erosions. And you can see we did the all kind of, again, maps for both the factors. And let's go. And you can see these are the sediment yield along by the EPA models. And again, all these you can see along Yadungulu fault, again OST, again Rolef fault, all with faults, these sediment yields are related. So what we want to say here is that when the sediment erosion is related to the tectonics, and tectonics, the discharge based is also related, and most of the landslides occur in these areas. So you can see here the incision rates also are related to the same thing as you see with the MCT1, MCT2, and OST in the Tista River. Similarly, MCT1, MCT2 in the Bhagirathi and Alaklanda Valley. And we tried to have through different models, we tried to relate the incision rates. And finally, our conclusion was, and this is the rainfall, which we first took the rainfall, observed rainfall, and we completed, we just reorganized it and observed the differences between the two and recalibrated the TRM with the observed data. You can see here how we have calibrated. And then we can see the TRM pattern data with the tectonics here also. And you can see here, the annual precipitation is very high in these two zones, the rainfall data. And most of the earthquakes are also in this season, which is occurring. And similarly, we have already showed you these two diagrams. So the whole thing, rather we have done it with the erosion rates through the Russell or EPM model, or we have done it through the discharge and this, and also the orographic precipitation, which you can see here, is quite relatable. If you put all the landslides, we have another diagram which I couldn't show you here. If we put all the diagrams of landslides over here, you can see that most of the orographic portions are close to the MCT, covering close to this zone, and the rainfall and the earthquakes and the landslides happens in this areas. So this is some work which is already going on in different parts, in different ways, and we are trying to look into the relationship between we had a paper in 2006 on the similar patterns on the orographic reviews in the Kedarnath, and we have checked that Kedarnath being again the same portion for the same as the orographic barrier occurs over there also. It was a heavy rainfall plus the climate change which affected melting of the glaciers, which affected the total area and the natural hazards occurs. In total, what I want to say is that all these things are related. The climate, tectonics, rainfall, orograph, as I've shown with the orographic barrier, they're all related together. And if you see the exhumation rates, it is definitely related to uplift also of the Himalayas. If you see the neck points, it is definitely related to the faults and thrusts. And you can see that close to the neck points as well, these earthquakes, earthquakes, not only earthquakes, but also the landslides and other hazards happen. Just to tell one important thing is that we have tried the data of discharge in the two earthquake prone areas, which were 1998 and 2000 earthquake in the Garhwal Himalaya. And we tried to check that what was the erosion rate during that year. And you will be surprised to know when this earthquake happened, it was more than 10 times. The erosion, the sediment discharge, and the yield, the silt yield was 10 times more than what it happened in the general average periods or even in the extreme periods. So what I want to say is that there is a definite correlation, because when you have a loss of mass, there is an uplift of the Himalayas, and when we have uplift of the Himalayas, the stress is released, but when the stress comes again, so it is the whole process is undergoing, which is affecting it is tectonics, climate, orographic area, everything is related together. And if we see that most of the hazards are occurring, so what we are trying is that we are trying to identify the orographic areas. The orographic areas, there is something like 11 orographic regions in the place. And in these orographic regions, we are trying to see that how many disaster prone areas are there, what are the slopes there, what are the lithologies there, what will be the effect, so that we make a map of these orographic zones and try to see that nothing much more urban comes over here and it is preserved in a better way, so that less disaster happens in this area. Thank you very much.
Thank you, Professor Chandrasekhar Dubey. So it was a very nice talk. I think any questions, please, maybe very short questions if you have. So, I think no questions from the audience. So once again, thank you, Professor Dubey.
Thank you.
For such nice talk from the Himalayan terrains. I think now we have to conclude this first session, that is the inaugural session. And Professor Mukesh Pandey, the Vice Chancellor of the Bundelkhand University, sent his message that good wishes for this webinar, and he is unable to present because he's very busy scheduled today. So I would like to request Professor Ramota, please give the vote of thanks to all of these delegates and other participants too.
Thanks, Professor Vinod ji. Very good afternoon. I hope मेरी आवाज आ रही होगी.
Yes.
Very good afternoon to all. First of all, I welcome all resource persons, subject experts, and participants on behalf of organizing committee and on my own behalf in the third international webinar on natural hazards and management, which is very important for the present scenario of the world. I thank to Professor Sergei Svetov, Director, Institute of Geology, KRC, RAS Petrozavodsk, Russia, and Professor Vinod Kumar Singh from Bundelkhand University, Jhansi, and convener of this webinar for highlighting the MOU between Bundelkhand University, Jhansi, and KRC Petrozavodsk, Russia. Hope this MOU will bring some important research contribution in the field of earth sciences for social benefit. Some students will also be benefited working with Professor V.K. Singh. Thanks are also due to Professor T.N. Singh, Director IIT Patna, India, for very important suggestions regarding rock mass instability in hilly regions. Professor C.S. Dubey, Vice Chancellor, K.R. Mangalam University, Gurgaon, Haryana, India, for giving valuable information regarding natural hazards of Garhwal Himalaya, especially based on tectonogeomorphic features, and Professor Dhrusen Singh for very informative lecture on impact of climate change on society. I also thank Professor Mukesh Pandey ji, Vice Chancellor, Bundelkhand University, Jhansi, who has already suggested many things for this webinar. Now, scientific session will start, which include topics such as mining hazards, seismic hazards, land, soil degradation, landslides, effect of climate change, water scarcity problem, environmental aspects, etc., there is a need to fight against such disasters, find the solutions, and make society aware of the consequences. The proposed webinar is aimed at gathering already collected data and seeks from researchers the techniques, models, and technical issues. We will discuss geological, morphological, and anthropogenic aspects of hazards, talk about the latest and new techniques in the subject, and disseminate the knowledge on hazard mitigation, management, and monitoring to combat the threat. Simulation, prevention, general awareness, and treatment of landslides will also be considered. This international webinar will bring together various teachers, geoscientists, technologists, engineers, environmentalists, geographers, etc., in order to discuss various strategies for environmentally safe developmental activities, and finally, awareness to common mass about environmental degradation and sustainable development. Again, I thanks to all. Now, the session will be conducted by Professor V.K. Singh, convener of the webinar. Thanks to all.
Okay, thanks.
Now, Professor V.K. Singh.
Thanks, Professor Ramotar. Now I would like to call Professor Vitali Shekoy. Please unmute your voice.
I am here.
Now, okay, yes. So, from the Institute of Geology, Karelian Research Center, Petrodavsk, his topic is the basics of safety in the operation of mining and industrial heritage in Karelia. Please continue. Share your topics.
Okay. Do you see my screen?
Not yet.
Not yet, but wait a minute.
You remember how to share?
Yes.
Okay.
And now?
Yeah.
Now it's okay. So
okay.
Yeah.
Let's go. The used mining space is becoming an increasingly significant factor in the development of tourism due to its unusualness. Different from the widespread places of work of modern man, the small mining spaces have developed their own specifics for the use of equipment, its size, shape, unusual and mysterious mine workings attract a wide mass of people who are looking for new impressions and new information. Underground mine workings, natural caves, have a set of such attractive properties. However, this causes the problems of their safe use, which we will talk now about. Okay. First of all, introduction or content of my talks. I will not comment. You can see it, but then I will stop on every of that 8 topics to explain my thoughts about that. First of all, this year, the Institute of Geology of the Karelian Research Center of the Russian Academy of Sciences is completing a project related to the assessment of the possibility of application the used workings and quarry space for tourism purposes. We have, of course, a lot of problems, not the problems, but a lot of challenges with that resources, because the future of Karelia is the fact that such workings, which have historical value, first of all, and they were developed by underground or by quarry many years ago, and they were abandoned more than 100 years ago. So the question arises, should such workings be served by special personnel, or is it enough to develop a number of measures when ordinary qualified personnel will ensure safety control? What does it mean? When we are working with a mine, we understand that only miners, only people with a special education should take part in that kind of work. But when we work with the museum, of course, most of that workers, they are not professionals. And what to do in the case of the underground museum? Should we use the special miners, which of course will be not provided with full day, but they are high educated and they have to have a rather good salary. So it will be a little bit maybe expensive for such kind of museum. What to do? Should we use them? Yes or no? That is a question. Several words about underground space. We should stay immediately formulate restrictions because underground space refers to everything that is in the underground space, and you can understand tunnels, metro, underground parking, underground storages, gas, oil, etc. And at that queue, we have also museums in underground space. What's the difference between such kind of museums and ordinary underground space which we use every day, like metro and parking and so on? First of all, the difference is that lifetime of ordinary workings from the ordinary shaft is determined by the period of the shaft work. Then the lifetime of museums begins only after the mining work has been completed, has been stopped. Thus, if that workings and shaft was, so to say, calculated or projected to work for a certain amount of time, after the shaft will be closed, it should be closed too. But in our case, especially if we have the historic workings, historic shafts, they start to be applied far from the closing time. In our case, it's more than 100 years. It's a problem. It's a thing which we have to take into account. Underground space as a museum space has a set of special natural characteristics that distinguish it from the above objects. For example, you can see old mine workings in the Reiche mine, the Freiberg, Germany. On the left, you can see the old gallery at the depth of the 150 meters, and along which the miners moved to their working place at those time. On the right side, you can see the path from one level to the mine to another. A feature of the mining space used in museum practice is the requirement for the authenticity to those workings that were used in the certain historical period. And they were used without preservation or with preservation of drilling traces. Mine surveying marks Christian symbols carved in stone by devout miners, and the type of support that was used at that time. The original objects of the show keep the spirit of history and the breath of those miners who worked in these workings many decades and centuries ago. Thus, we have to keep that historical things, that breaths, that soul in that minds, if we'll use it like a museum. So authenticity is the most important thing. And of course, safety. About safety, we will say for them. So initial conditions. In accordance with the current legislation, subsoil within the boundaries of the territory of Russian Federation, including underground space and minerals, energy, and other resources contained in the subsoil are state property. It belongs to state. The use of underground space as well as other minerals is permitted only upon receipt of a special license. It states the fact that nobody can use that resources without the special permission, special license, which will be provided with the ministry, depending on the level of the resources, the local ministries or the federal ministry. It depends on the resources, on the amount of that resources, and so on many other requirements. Briefly speaking, in Russia, the federal legislation does not actually contain special rules governing the provision of land plots for the construction of underground facilities in mined workings. So it means that if for every resources which we have in our territory, we have the special rules, we have the special requirements, documents, which define the situation, what to do and how to do, and how to prepare all reports. The only underground space, underground facility, which could be used for different purposes. They have not such rules. To date, there are several dozens of different kinds of museums located in the underground space, I mean in Russia, but none of them has received such a license and exploit such workings based on their own ideas about safety. That's why we decided to study the situation, and we during our project we decided to propose several solutions, what to do, at what stage, and how it could be organized. The approach is that is applied to the management on mine workings adopted in the mining industry is cumbersome, complex, with high requirements for the qualifications of workers. I mentioned about that. And in relation to the mining and industrial heritage, looks very excessive, capable of simply blocking its use. So if we'll adopt those rules which now are used in mining industry, no underground museums will be organized. And we know about the experience of different use of underground space today, and also abroad. The world has accumulated vast experience in the use of underground space, from a complete ban on the use of underground space for tourism purposes, as is customary in Finland, for example, the Mining Museum of Outokumpu, to its specialized and integrated use in education and tourism, as it done in Freiberg Mining Academy, Germany, for example, at the Reiche mine, which we studied too. Main question. That is, take into account the specifics of underground space resource management, it is necessary to develop a set of measures that would address the following issues. That is to provide maximum authenticity of the underground mining space used as museum space, and to provide safe conditions to that visitors, including children, to visit such spaces safely while maintaining the stress, mental stress that comes with visiting such facilities. Visiting underground space every time is a little bit stress situation for every people who are, it depends of course on the depth, but even in small workings which are not covered with the concrete or another supporting facilities, it every time presses to the people, and it is very good for museum because those people have to feel new emotions in such conditions. Why we are talking about authenticity. So of course I cannot describe everything what we made. So solution of the problem is how we decided during our work is in creating of a methodological basis for assessing the resources of underground space, classified as a mining and geological heritage. Preparation of requirements for the study of the potential of mining space, including underground, and expansion of opportunities for the use of mining and geological cultural heritage, both in Karelian Republic and in the Russian Federation itself. This is the Ruski Ala at the construction stage several years ago when they built some underground facility, and as a result of a methodological basis for assessing the resources of underground space, classified as a mining and geological heritage, was created methodology with a description of every stage, and the first stage, of course, and maybe the most important, longest stage, it's a preliminary assessment of mountain space, because at that stage necessary to estimate not only safety, not only physical properties of the object, but also historical meaning, the value of that object in history, in our activity, in our past activity. So similar to the mining and geological assessment of mineral deposits by an expert methods designed to understand the scale of objects, its availability of information materials, and make a positive or negative decision on the possibility of continuing work and the next step in the further study of this object. Thus, we have at that stage, we have to decide, is it a valuable object, or could it be used as a museum or not? It is a very, very important step. And next, of course, next step is the study of working space. Next, it's design. And you see now in the screen construction stage. And as a result, exploitation of museum zone, museum area in the form of museum. Of course, that questions, that steps are described in our report, but it is impossible now to show it for you because it consists of dozens of pages. I want to remind you, and I presented that pictures 2 years ago in my report at the first conference. The Institute of Geology has patented a device, the essence of which is to install a laser rangefinder on a special reference base, which makes it possible to accurately position the laser ray at a controlled point. A regular measurement of the distance from the benchmark to this point make it possible to track possible movements in a section of the rock massive range and take measures to eliminate emerging threats or just rock movement. So it's one of methods which we propose to use for underground facilities because it is very simple, very cheap, and this method could be used also by not professional people. So because their work will be only to control, only to measure every day or how it will be installed, the distance to observe if they are in movement. If some movement will be founded, so it's a sign that it's necessary to make something to maybe to organize a safe use of the workings. So and as an example, I can say that we founded several such places in Ruskeala Mining Park, which were extremely dangerous. And of course, not we, but administration of the park, they removed that threats from the museum. And yes, I showed it. So for to use that kind of technology, so that methodology, user should install many such points. Of course, before they have to study everything to estimate pressure, estimate stress, etc. And then in some places they have to install that device to measure movement of massive or deformation which we can see in the massive. No, it's So I don't know what happened. Yes, the same situation for the surface. This is the west wall of Warri, which is very unstable, and to prevent its destruction, we also use this technology, and this technology in that case is even much more simpler than underground, because we use in that case 2 metal bolts, where we can, using that rangefinder, we can control this distance, which gives us possibility to avoid every movement. But you see that this fracture work is very big, and when it will be destroyed, when that fracture will be open, nobody knows. So in few meters, maybe couple of meters, 3 meters from this place, we have a wall, and then that lake. So we have control what's going on in that areas to prevent any damage, any possible threats. So the most important from this point, from the point of view of the organization of the safe use, and perhaps the longest period, is the first stage of this work. So to say, preliminary assessment of the mountain space, which should be done everywhere, on every mining area which is planned to be used as a museum space. So everybody who wants to use it as museum should, first of all, to make preliminary assessment, to install the net for observation, and only after the positive results, that place could be adopted as a museum. So our conclusion is very simple. So photogrammetric and engineering geological survey of mining infrastructure objects with the allocation of suspicious sites by an outsourcing company with a frequency of 1 year or more. Only at that stage we propose to use the specialists, so so-called outsourcing company, who are very good who has very good knowledge in that field, and who has who can come time by time, annually, or maybe if necessary, every month. But of course, it's senseless to use that museum, which should be controlled every month. So annual full control should be done with the outsourcing company who has the specialists in miners or in physics, etc. Second, establishment of net of special reference points on dangerous allocated places in order to periodically control their mobility with an interval of 1 to 2 days to several weeks. It depends on the situation. At least in Ruskiala, we proposed 1 month for such conditions. Creation of a network for monitoring deformations on the elements of an object. It is organization of periodic instrumental control, which could be done with the staff of the museum, and there is no need to have the special miners, special specialists, which will provide that kind of work, because it's a rather simple and even low-educated people can do it. And the third, in addition to this instrumental observation, it's necessary to organize daily visual control. And instead of conclusion, some ideas, so to say, we have, first of all, we have control in our underground or mining museum. Then we have first. The second, if maybe more important, we have control. And the third one, we have control. In that case, we will satisfy to the name of my presentation, basics of safety in the operation of mining and industrial heritage in Karelia. That's all what I wanted to say. Thank you very much.
Thank you, Professor Vitali Sheko. So really, it was a very nice talk regarding the safety of the minings. Any questions from the audience? Can you close your slides, presentations?
Sorry?
Please share off your
my presentation.
Yeah.
Yes.
Okay.
If somebody needs it, I can send you.
No. Kindly close your presentations now.
You mean open right now? Okay.
No. Artem, Dr. Artem.
Yeah, please close your screen. He means.
It is unshare your presentation.
Yeah, unshare.
We close. Sorry, I understand you. Sorry. No, because it's different screen. Yes, I know. So we'll try to find where is it.
Maybe I
stop the demonstration.
I hope Artem, I should go for the next to you.
Yeah. Yes. Wait a minute. Where is it?
Artem, you can share yourself. Then it will
of
delete
course,
it.
Yeah.
Okay. So the next talk is the Dr. Artem Lebedev from the Petrozavodsk, the same institute, and it is the topic the quarry blast, the main source of the seismicity in that region.
Okay, good day, dear colleagues. I'm glad to present a talk about quarry blast as the main source of seismicity of the southeastern Finland. You can disagree with the fact that a massive quarry blast is a very complex event. In the process of such as an explosion, a large number of wells are undermined in a short delay manner. Moreover, in order to reduce the seismic effect and increase the productivity of work during a massive explosion, several separately located blocks are worked out in turn. As a result of such as explosions, the explosive energy is released extremely unevenly, which leads to a complex structure of seismic vibrations. The mining industry is one of the sources of anthropogenic impact on environment. In Russia, as is the rest of the world, a large number of fire-rich explosions are carried out, especially during the open pit mining. For example, only at the open pits of the Kostomuksha region, about 50 large with over 500 or more tons explosions are produced per year. The mass of explosive used in a separate explosion for individual enterprises can reach 1,000 tons or more. Among the factors that determine the impact of mining on the geological environment, one of the first places in the terms of importance in the seismicity of the explosions. Any forms of technogenic seismicity that is formed after primary seismicity are reduced seismicity. Induced seismicity is the result of various human influences on the Earth's crust, taking place dynamically, slowly growing, static or periodically. the main characteristic feature of the induced seismicity is that the source of its manifestation is both its own reserves of elastic energy in the medium and the energy transferred to the medium during exposure. Induced seismicity usually manifests itself in the form of relatively weak shocks during technogenic impacts, both in the medium. A certain level of stress state triggers the activation of deformation processes. Hypercenters of induced seismicity, you can see them here, are usually located within the influence area of a technogenic source. Stress state in a rock mass around open pit changes gradually after breaking in benches. Here's an example of a series of aftershocks followed the earthquake in the central mine of Apatite quarry. Here you can see the earthquake epicenters registered by 3 national seismic networks on the Fennoscandian Shield up to 2020. The territory of Karelia has traditionally been considered aseismic. The territory of Karelia belongs to the zone where earthquakes with intensity up to 5 points in the MSK 64 scale can occur once every 500 years, with 6 points once in 1,000 years, and with 7 points once in 5,000 years. With an increase in the degree of interference in the geological environment, the establishment of real seismicity of a territory becomes more and more relevant, even for seismically weakly active regions. You can see them on the map. The Karelia looks like a aseismic region in front of the Fennoscandian Shield. Since the establishment of a Karelian seismic network on the basis of the Institute of Geology of the Karelian Research Center, we have the opportunity to collect and analyze data on seismic events occurring in the Karelia region as recorded by various seismic stations of both the Karelia and neighborhooding regions. To study the deep structure and seismic regime of Karelia, Institute of Geology scientists constructed a regional seismic network in 1999. Quarry blasts were mainly events recorded. The network was constantly updated. So in 2015, the Karelian seismic network consists of 4 wide-range seismic stations. Our seismological network is very young and new. Since 2021, we belong to International Seismological Center. The typical scheme of Karelian seismic network is shown here. Seismic data are synchronized in time with the GPS receivers. Data are recorded automatically in the station computer memory and transferred to the storage server. In the real time, we receive records for future processing and monitoring and complying catalogs of seismic events of the studied territory. Okay, large-scale open pit mining in the deposits with block geological structures under the action of high gravitational and tectonic force fields leads to the principal stress distribution and rotation that can cause rock bursts and technogenic earthquakes. The Fennoscandian Shield is a conservative structural unit, which has preserved its structural integrity and has maintained its elevated position for 1.5 billion of years. Estimation of seismological potential through geological studies of faults is an important step in the seismic hazard estimation and mitigation. Some faults can produce high magnitude seismic events. Here you can see the scheme of connection of paleoseismogenic structures with the latest structural plan of Karelia and the epicenters of the historical earthquakes. Our talks, discriminating naturally occurring earthquakes from man-made origin seismic events is not always straightforward. Small seismic events that are located within the Karelian seismic network will often have an error ellipse of 10 kilometers. as a product of the seismic monitoring network density. Karelian seismic network extension register mainly local blasts and local events near the border in the Murmansk and Arkhangelsk regions, as well as in Finland and Sweden. In addition to local events, the Karelian seismic network register teleseismic events. Low magnitude earthquakes occur in Karelia 1, 2, or 3 times a year. During the continuous monitoring since 2050, all of the events we registered in the north part of Karelia had the magnitude from 1.5 to 2.7. Our talks involves not only forecasting intensity of expected earthquakes, but also assessing the possible seismic effects of man-made region. One of the significant sources of seismic disturbances is mining production. Numerous cases of damage of structures and buildings produced by industrial explosions are known in the practice of mining companies. We have evaluated the basic parameters of local seismic disturbances caused by explosions and quarries and have obtained estimates of maximum possible amplitudes of explosive impact at different distances. We use data recorded at different distances from quarries from 15 to 400 kilometers during explosions of different powers and different scheme of blasting. Most of the explosions had the total yield of explosions in the range from 5 to 1,250 tons. Quarry blasts remain the more striking seismic events in the seismically inactive territory of Karelia. The study of quarry blast has special interest because it can provide a basis for approaching many seismological problems. Seismic catalogs are now complete by studying the type characteristics of seismic signals from numerous quarry blasts as a source of disturbances in the study of low magnitude earthquakes. Here you can see an example of explosions in the Kostomuksha quarry. Fragments of 3 component records of the explosions at the seismic stations of all 4 seismic stations of Karelian seismic network. Okay. According to the temporal dynamics of explosions at the Kostomuksha quarry, according to the temporal dynamics of blasting operations, the smallest number of explosions was recorded by the stations of Karelian network in the summer. You can see them here. The largest number of blasting operations was carried out in December and December 2019 too. According to the consolidated catalog, weekend explosions appear to be in isolated cases. An important parameter in the analysis of blasting operation is the time of blasting operation during the day. Most of explosions are carried out at the same time in the interval from 9 to 11 UTC. In general, it can be seen from the figures that all explosions fall within the interval from 4 to 18 and not carried out later or earlier. Here you can see the map of Karelia with registered seismic events. Here the red dots show quarry blasts and red stars show earthquakes that happened in Karelia with magnitudes up to 2. Based on the results of the continuous observations, consolidated catalogs of seismic events with magnitudes from 0.5 to 2.7 were complied. For comparison, data from the Finnish seismic network were taken for the same period, which showed a insignificant scatter and reliability on the data obtained. The strongest and most frequent technogenic events for the studied region with magnitudes up to 2.5 are still recorded in the Kostomuksha region. The southeastern part of Karelia is also worth noting. Seismic events in the western region are less weak than those observed in the Kostomuksha region. Seismicity in the above areas is recorded not only by the station of Karelian seismic network, but also by seismic stations of Finland, Norway, and neighborhood regions. Kola and Pulkovo. This feature can be explained by the fact that these are border areas, and the magnitudes of events are higher than 1.5. If we consider the eastern part of the Karelia, then it is worth highlighting the following areas: central and eastern part. Events in these regions are weak, with magnitudes of 1.5 or less. They stand out mainly in the records of a Karelian seismic network, and where technogenic load is half of all active blasting operations in the territory of Karelia. Okay. Quarry blasts, some conclusions, in the territory of Karelia had a wide range of total yield of explosions from 5 to 1,250 tons and up to 350 per year. Large-scale open mining in the deposits with block geological structures under the action of high gravitational and tectonic force fields leads to the principal stress redistribution and reorientation that can cause rock bursts and technogenic earthquakes. The increase of seismicity of mining territory raises danger of exogenous geological processes. Wherefore, it's necessary localization of modern activation areas of tectonic structures with induced seismicity for the system of complex geophysical monitoring of shallow surface of a region. The experience of recording seismic explosions has shown the need to study when assessing seismic hazard. Thank you for your attention.
Hello, Arti. Thank you, Dr. Arti Lebedev. So it was a very nice talk. Any questions, please, from the audience? Then should we go continue? So, Dr. Lokeshna, please open your mic. Unmute, please unmute. And say some words. Dr. Lokeshna. Dr. Ramotar. Can you trace him here?
कौन?
Lokeshna, Dr. Lokeshna.
वो उनके अभी just जो है नेट चला गया है.
Okay, so then we go for the Professor Y.P. Sundaryal. Is here?
Yes.
Okay, so kindly open your slides. So Professor Y.P. Sundaryal from the Department of Geology, Hemoti Nandan Bangla, Garhwal University, Srinagar, Garhwal. His topic is climatic induced disasters with special reference to Uttarakhand Himalaya. Please, Sundaryal ji.
Can you see my slides?
Oh, yes. Kindly share the full view.
I'm trying to share the full view. Okay. Yes, now?
Yes, click it. Okay, yes. Please continue.
And the slides are also moving?
Yes.
Okay. So, my topic was the climatically induced disaster with a special reference to Uttarakhand. And I know that Professor Dhruv Sen Singh and then Professor C.S. Dubey, they have also worked in the Garhwal Himalaya, and they have also said their scientific view on the disaster takes place in the Uttarakhand. So the disaster, as I have mentioned, that mainly disasters is possible by two factors scientifically. One, we say the climate, and another we say that it is tectonics. And I relate tectonics directly with the earthquake, and climate. We have the cloud burst, we have the torrential rain, in a particular area or along one valley, because due to climate change now, we have the different type, we're seeing the variation in the rainfall pattern also. So my main topic is the climatically induced disaster. And these climatically induced disaster, as I mentioned, that due to high rainfall and then due to the snow avalanches, sometime rock and ice avalanches, as it happened in 2021, the Rishiganga event. I will show you some slides of the Rishiganga event also. So there are two broad reasons for the, if I collect all these disasters from 1894, then 1970, then 2000, then 1998, then 2001, then 2013, and after that, the Rishiganga event of 2021. So the broad reason is for this type of the disaster or flood, mainly the glacial lake outburst flood and the landslide lake outburst flood. So these are the two, and this is happened in the Rishiganga. This is the map of the Rishiganga. Here we have a village, Rani, and here we have the Dhauliganga, and this is the Rishiganga. If you can see this cursor, so this is Rishiganga, and this all white, what you are seeing here, actually this is the glacier covered area. And this Rishiganga is a glacial fed river. We have only two rivers in Uttarakhand Himalaya, which are spring fed. One is the Ramganga and another is the Nayar. Rest of all the rivers, we have the glacial fed river. And actually this Rishiganga falls in the NDBR region, Nanda Devi Biosphere region, where we have 8 glaciers. And in the Nanda Devi Biosphere region, and its name is Nanda Devi, then we have the highest peak of our country. Its height is 7,816 meters, Nanda Devi. So this Rishiganga is a glacial fed river, and what happened in on 7 February 2001. This is the satellite picture of you can see the February, month of the February, keys, and then the upper one is the oldest. It is the January photograph, and now you can see that this much of the mass in which the rock and ice both toppled, and on the basis of the various worker, the thickness of that avalanche, which was the mixture of the rock and ice mass, its thickness was 70 meters, and the elevation drop, the toppling of that mass was 1700 meters, and its volume was 23 million cubic meter, and the potential energy generated 0.93 petajoules. So this I have taken from the paper of Pratima Pandey et al. That published in the Journal of Remote Sensing, and that paper published in 2021. Then one more paper, Talur et al. 2022, they estimated that width of the rock slide surface was more than 755 meters. Then its length was the 1,181.2 meters. The covering area was 0.51 square kilometer. And this I have taken from the Talur et al. And we worked, my student Naresh Rana and myself, we have published 3 papers on this Rishiganga event. And we, on the basis of the high resolution satellite data, our estimate is the total rock and ice mass is the 1.0 into 10⁻⁷ cubic meter. And then volume of the deposited debris from the sediment was very high. It was 1.2 into 10 raised to power 7 meter. Now this is the picture of the, now you can see that this is the Rishi Ganga. This is the Rishi Ganga and this is the Ronthi, small stream Ronthi. And this Rishi Ganga and Rothi, both actually this is the confluence of the Rishi Ganga and Rothi. And you can see that there was a lake formed along the Rishi Ganga, and here when the Ronthi meets here at this confluence, then we know this river as the Rishi Ganga. Now you can see this is another view of the, this is the view of the lake which formed due to the blocking of the debris or muck. Muck is human anthropogenically induced material, but this debris actually choked the Rishi Ganga here, and this is the Ronthi river. Actually, main culprit was the Ronthi Ghat, but Rishi Ganga is a famous name, so people know it as a Rishi Ganga tragedy. But this all happened along the Ronthi Ghat, which is a tributary of the Rishi Ganga. And then you can see that there was a hydro project of 11 kilowatts that was completely washed away. But this picture is the picture of the Tapovan hydro project, which is under construction. And about 2,206 labor was working on that day when this incident happened on 7th February. And here you can see the Tapovan condition of the Tapovan hydro projects. These are two, you can compare now this picture. This is the old picture and this is the new picture after the disaster we have taken. This entire bridge, here we have the Rani village, where the Rani is famous for Chipko Andolan, Chipko movement. And a lady, her name was Gaura Devi. Actually, she initiated this program, which we know as a Chipko Andolan. So this is the village Rani, and you can see that this entire bridge we have shown here with the dotted line washed away. And if this video this is the video, live video of the Rishi Ganga tragedy. This all along the Rishi Ganga.
Sundaryalji, it's live video means it is currently?
No. Actually,
okay.
This video was taken by the villager. They made this video on 7th February.
Okay.
So just to have a look what happened actually in the Rishi Ganga. That's why I showed this video. So Rishi Ganga flood was triggered actually by the mass wasting, and as I already mentioned that actually it was the rock and mixture of the ice and rock, and that fall that toppled from 6,300 to 4,000 something meter, and its difference is 1,700 meter. Then what happened? If we compare the 2013 and this Rishi-Ganga event, actually the earlier people also said many things, but what we noticed and what we published and what we have seen, that when there is high concentration, if high amount of the sediment is involved and the amount of the water is the less, then what happens? Bigger boulder comes in the buoyancy. And in the valley, when they are being transported due to their buoyancy nature by that particular river, due to their impact on the valley walls, numbers of the landslide they creates. And when that hypoconcentration flow moves downwards, then more and more sediment generated. So I have just shown you this Rishi-Ganga video of the 7th February. It was a live video, and I have taken from the village, and this video was available on the YouTube also. But on that day, our local and state administration alarmed all people to vacate the river bank immediately. But the amount of the water was so less that this happened at around 11:20 a.m. morning, when people came to know that this Rishi-Ganga calamity happened. Then Karnaprayag, from that area, Josimat to Karnaprayag, it is about 70 or 80 kilometer distance. But till 5 p.m., no flood water reached even up to Karnaprayag. So this was a tragedy, but the science behind it, the damages took place because in the narrow valley, as Professor C.S. Dubey and another speaker, they mentioned that landslide took place, that dams the flow of the river, then again it breaches, and this type of the incidents happens in the narrow valleys. Now, I will not speak much more about the Kedarnath disaster, but here I would like to tell you about one valley, what happened. In 1979, we have 50 people, they died due to the cloudburst. In Ukhimat in 1998, 107 people died, and on the same day in the Kali Valley, if you remember, 200 I think hello. And on the same day, if you remember that Pratima Bedi, along with many pilgrims, they were on the way to Kailas Mansarovar. This happened on the same day when this Ukhimat tragedy happened in 1998. Then Fatabung tragedy happened. This was again due to the torrential rain and cloudburst, 27 people. And then Ukhimat tragedy in 2012. Again, the cloudburst took place here and 66 people lost their life. But if you look at the Kedarnath, then 7,000 approximately, and this is the data which is approved by the government. But non-official sources says that the casualty was more than 20,000. Some people think that this was the glacial lake outburst, because the Chorawari Lake or Gandhi Sarovar Lake, Professor Dhruv Singh also mentioned that this Chorawari Lake, and this was the data I have taken from my friend D.P. Doval, And they said that the area of this Chorabari lake was 400 into 200 into 20 meter. 20 meter is the depth and this is the length and 200 was the height. If you calculate all this, considering that the depth of the water was 20 meter at that day, then you calculate, you can imagine that along with the torrential rain, this also supplemented the disaster. But in the month of October, when the district administration allowed us to visit the Kedarnath, myself, Dr. Professor Pradeep Srivastava and Perumal and my student Naresh Rana, Pinky West, we went to the, actually to see the lake, Chorabari lake. And we found that there was only 1 meter to 1.5 meter water mark was there. And the entire lake was full of the sand. So, and these are two pictures. One, you can see that picture of 1882 and another picture of 2008. And this I have taken from DP Doval, and this was the GSI scientist, geologist. And now you can see that the change in the land use. Here you can see the temple, and here you can see only the top of the temple. And this was the Chorabari lake. Okay. Now, this is our picture, but I wanted to tell you one thing. This is Saraswati River, and this is the Mandakini River. And the actual course of the Saraswati River was like this. And the original confluence was here. If you can see this cursor, then what people did? They constructed a wall here, which is clearly visible. And they made an artificial confluence of the Mandakini and Saraswati River just upstream of the Kedarnath. Okay. But when this Saraswati and Mandakini River got the very good amount of the water due to the high rainfall, Saraswati River occupied its old course and washed away all these infrastructure which was constructed along the path of the Saraswati River. And in next slide, you can see here. This is the Saraswati River. And this river not encroaches or not made any new confluence. The original confluence and original path, this Saraswati River occupied. This is another picture of that photograph. Now you can see this is the condition of the Chorabari lake. It was full of sand. So actually, and this is, you can see, this is another picture of the Chorabari. Here, you can see that we have the laminated sand here. And this Chorabari lake was having only 1 to 1.5 meter water at that day. Here is my student Pinky Bis. He is now scientist in the Wadia. And here you can see that this is the view of the Chorabari after its bleaching. This is the Rambada, and it was completely washed away. This is the Sonpriyag. You can see the condition of what happened in Sonpriyag. And this is again a Kali Valley, one tributary of the Mandakini. Here you can see that this 2 to 2.5 meter deep cracks evolved around a village. It is known as Kunjeti. And here we have a Kali River. So this all happened in 2013. So we have discussed a few picture of the damage of 2013. I'm just showing you. And this is the, now that was the Mandakini Valley. What happened in the Mandakini Valley? When we will construct you can see the multi-story building. People constructed this on the riverbed. So we are inviting the disaster. And this is a village which is known Pulna, and Apada se pehle Pulna gaon, or after disaster, what happened in the Pulna village in the Alaknanda Valley. Pulna village is just after Marwadi, below the Josimat. And these are some damages. Now here we have our university campus, HNV Garhwal University campus, and you can see that this is the old, this is our hanging bridge. And what happened? You can see this is the muck deposited by a hydro project which was under construction in the Srinagar Valley along the river Alaknanda, and they deposited that muck in this space. And you can see this is the muck. This muck actually played a very crucial role. And here we have some picture of the ITI Srinagar when presently the NIT Uttarakhand is also running here. Now you can see that all that muck along with some sediment, this muck buried all these buildings. And this where in this first picture, this is a double-story building, and you can see that its ground floor is completely buried under the sand. And these are another pictures of the same ITI. This picture, you can see that this is, we have a paramilitary force, its name is the SSB, and they constructed a very nice, beautiful administrative block there. And after June 2013, you can see that what happened. But again, I would like to recall or remind you people that this was also constructed on the unsafe site. Now we have the 1970 flood, which was considered the highest flood in the Alaknanda Valley. But in 2013, we measured this. It is the level was 4 meters above than the 1970. Now I have two another pictures. I have just discussed this Mandakini Valley 1998 tragedy. This is the you can see that a massive landslide took place along the Madmeshwar Ganga. This is the Madmeshwar Ganga. And two villages, one was Bhenti and another was Pondar. They completely buried, and 107 people, they lost their life under this huge mass, huge debris, rock and debris mixture. Now this is the another picture, and this is of the Bhagirathi Valley. Bhagirathi Valley in 1978, one tributary stream Kanodia Ghat, it was blocked due to the landslide. And when this natural dam, which was actually the landslide dam lake, that when breached, it washed away completely. Josiara is a small township just downstream to Uttarkasi, and it was entire valley of the Bhagirathi was badly damaged due to this climatic induced disaster in 1978. But now I just wanted to tell you that in 1893, due to cloudburst, about 5,000 million tons of the rock mass that fall in a valley, which was the Alaknanda Valley, but its one tributary is the Birahi. Birahi, if I tell you its geographical location on the basis of the popular name, then Birahi is in between Pipalkoti and Chamudi. So this much of the mass that blocked Birahi Ganga and that form a natural dam. If you see the height of this dam, it is higher than the Terry Dam. Its height was 275 meters. And this happened in the month of September, when the monsoon is in its diminishing phase. So what happened? A lake was formed, which was 5 kilometers wide, and its top surface, summit wideness of the summit was the 600 meter, and height was 275 meter. And then at the time, here we have a picture of two very renowned geologists, Hem and Ganser. And this picture was taken early 1930s. And now you can see that this is the picture in 2008 we have taken. And this was the lake which was formed in 1893. Okay, this is the present picture, and this is the remnants of that lake here of 1893. And then it breached half, this dam, natural dam breached partially in 1894, and it was completely breached in 1970. Now, if you can calculate that after 77 years, this lake was completely breached. Now, just say that what at the time, Lieutenant Colonel Pulford, he was the superintendent engineer in the PWD, and Pandit Harikrishna Pant, he was from Kumaon region, but he was the district surveyor of the Garhwal region. And the administration, the government, British government told these both, you will have to monitor this lake. And what they did, they established, just what I want to convey, that today our technology is very high. In 2021, 2013, we have the mobile, and we have the Doppler, and we have this high resolution satellite data. But you just look what was in 1894. They established a telegraph system from Birheganga up to Haridwar. Okay, and they changed the pilgrimage footpath, and what they dismantled the 8 suspension bridge. And I will not go in much detail, but what I want to say, in 1894, the flood frequency was very high, but there was no single casualty happened along the valley. Then in 1976, after 76 years, Alaknanda witnessed another major flood. And this major flood was attributed at the time, people say that forest felling is here. So due to the forest felling, the soil rate of the soil erosion is very high. But in 1970, when we have our own government, we have our own technology, at that time, here I have mentioned that a convoy of 30 buses of the pilgrims washed away entire region of the Belakuchi along with these 30 buses in the Alaknanda. And about 400 pilgrims, they were en route to Badrinath, and they saved because the police constable guided them to go uphill, and they ran uphill to save their life. And in 1970, 13 bridges were swept away. And as I have mentioned that there was a huge loss of the property.
Sir, conclude.
Yeah, I'm concluding. This is my concluding slide. Actually, what is needed? Climate will play its role. So what is the needed? Basin-wise action plan needed. Then we will have to integrate and focus our approach of the research or approach of the planning to generate the data and to predict the disaster. We should install the high-tech instruments, and the geoscientists must also contribute as a planner, and government should include the geologists in the planning. So after that, the hot spot should be identified, and then detailed geological mapping may help in the future planning. So with this, thank you for giving me about, I think, half an hour. So thank you, Professor Vinod Singh, and thank you, Professor Ramatar Singh, and all the participants of this international webinar.
Okay, thank you, Professor Sundaryalji. So maybe we don't have too much time for the discussions. We will discuss later on with your personal mails and other meetings. And is Professor, is Dr. Lokesh Sinha is able to connect? Dr. Lokesh Sinha?
Yeah, I am connected, Vinod.
Okay, so please, thank you very much, sir. So, Dr. Lokesh Sinha, he is the ex-director of the Defense Terrain Research Laboratory, DRDO, New Delhi. And his topic is avalanche mitigation and control. It's okay, sir?
Yeah.
Okay, so please continue, sir.
Good afternoon, everyone. My topic is not exactly a research paper. It's something on the avalanches, because most of the people, they are talking about landslides and other hazards. I thought avalanche is a major hazard in Himalayan terrain, particularly in the higher Himalayas. And
it is possible to make full slide there.
Okay,
Not,
1 second.
Okay, it's possible. Click it. Okay, thank you, sir.
So these avalanches, generally the people, they live in the areas where avalanches are least. Mostly with the landslides in India, we are facing this problem. But on the higher Himalayas, particularly higher reaches, we are facing this problem, and the most or the severely affected is our armed forces. So as a part of the Defense Research Organization, it is our charter to predict these avalanches and save the lives of those soldiers. So in my slides, I'll cover mainly what are the mountain gravity-induced geohazards in Himalaya, just a glimpse. Then how we are doing mapping and monitoring of avalanche hazard. Then how we are assessing these avalanches and forecasting it. And finally, some of the control structures I'll show. So avalanches generally in the higher ranges of Ladakh, in Himachal Pradesh, Uttarakhand, Sikkim, and Arunachal Pradesh. And we are present in almost all the places. Our labs or their units, along with the scientists and technical staff, they are continuously monitoring it right from the end of October till April or May every year. So mountain hazards mainly are the snow avalanches, as I am discussing in this lecture, landslides, rockfall, and one of the major disasters in higher reaches are glacial lake outburst flow. Apart from that, we can encounter debris flow and flash flood also. So DGRE, my lab, where I was posted a year back, is working for mapping, monitoring, and risk assessment of geohazards, complete geohazards. This all we are covering, but today's lecture I'll cover only the snow and avalanches. So we have our presence in every location like Ladakh, J&K. These are our observatories. These are automatic weather stations, these many numbers. Our cell in all the units from J&K and some of the mountain and meteorological centers we have opened in these areas. So what is an avalanche? Avalanche is a rapid flow of snow down a slope, and it can further be classified into 4 groups. And in India, we are experiencing all the 4 types of avalanches. First one is the loose slow avalanche. It is common on steep slopes and are seen after snowfall. It's not quite dangerous. It is a wind blowing these fresh fallen snowflakes along the down slope. These slow avalanches, sometimes they trigger the slab avalanches also, and they are characterized by the fall of a large block of ice down the slopes. And this is the major concern because these are really creating a havoc in the higher reaches, and we are encountering it particularly from November till March, April, you can say. So roughly 6 months, we are facing this problem of slab avalanches. They are maximum in January, February, but from November onwards, it starts. 2 days back, there was a avalanche in Almora area, and 3 of our soldiers, they died in that. Despite of our warnings in those areas, because of the operational commitment, their movement we cannot restrict. So sometimes they get affected by these avalanches. Other is powder snow avalanche, and the last one is the wet snow avalanche. These are also quite dangerous as they travel due to friction, and it collects debris from the path with ease, and the snow along with the debris comes down the slopes, and it creates a deadly situation in those areas. So for a particular reason, like in India, you all know about the Shyok River. So Shyok is a tributary of Indus. So I am showing just the Shyok River basin, the total overall roads and routes length in that particular area, as you can see in the upper right corner, is quite a large number of roads have been constructed for the movement of our vehicular traffic in those areas to supply the goods to the soldiers at the border areas. And the avalanche is affecting not only the roads, but the army camps in that area. So we are periodically monitoring those camps. We are telling them the exact locations where they should be and which are the portions they have to leave so that they should not face these avalanches. But sometimes due to some need, we cannot shift the camps. So that time we are constructing some of the structures to protect the camps in those areas. So what are the causes of these avalanches? So the top 4, you can say, they are the dynamic causes like weather, temperature in that area, sudden increase in the temperature during those winter months, and rapid snow precipitation, the snowpack condition, and the wind direction. These are the 4 dynamic things which we are continuously monitoring from our station in those areas. Our people, they daily go out in the winter to collect this data, and they send those data to the base station at Chandigarh, and from there the prediction and forecasting is being done. The other 4 are more or less static things: slope steepness, slope orientation, terrain roughness, and surface or vegetation cover, you can call it. So this, once you map it, generally they are not changing. Very little changes are there. So those also we are monitoring, but that can be done in any summertime also. So that is not the main thing for which our people and lab is situated in those areas. Top 4 we are monitoring continuously for 6 months in those areas, and based on these data, we give the predictions. The top one is the automatic weather station. You can see we are measuring the wind speed and direction, relative humidity, precipitation, snow precipitation, the atmospheric pressure, how much solar radiation is in that area, and total snowpack height. So different instruments in this AWS is there. They have their own power pack also. Solar panels we have given, solar battery is there, and a GSM connection so that the data can be directly transferred to the local station in that area, and from there we send it to the base station. In the lower left corner, you can see how we are measuring the snow conditions. Actually, once the snow falls, it gets accumulated in the form of a layer, and it metamorphoses with time. So we are measuring the metamorphosis and the conditions right now, because at a moment, once it reaches that critical value, the avalanche comes. So from here, from the field, we are measuring the snow conditions and how it breaks. So we have a cold lab in Manali, wherein we create the snow here in this photograph. You can see how we create the snow. And once the snow is created, then we compact it and then we measure the cracks and all and its metamorphosis conditions in the lab, so that it can be correlated with the field data, and based on our research experiments we predict the avalanches. This is the operational avalanche forecasting flow, how we do it. So from the automatic weather station through satellite, the data comes to the base camp, and from the field stations, the total snowpack, the precipitation, and the condition in which at present those snowpacks are. As the avalanches progress, I mean the triggering of avalanches, just before that, small cracks and all will be developed. So those cracks and all are being measured in the field with some of the instruments. In my few coming slides, I'll show those. And based on that, we get all the data from our RDC and MMC located in those hilly terrain. And finally, we give the prediction from our lab at Chandigarh. And this prediction we give for 24 hours, 48 hours, and 72 hours. We have our stations for the prediction of the snowfall in the coming 3 days also. So based on our prediction and the snow condition in that area, we give the avalanche warning and forecasting. For the armed forces, daily at 3:30, we send it to the forward areas at all the camps located at those locations. Then I am coming on the avalanche mitigation strategies. Actually, if we have to control the avalanche, we have to control it at all the 3 zones. The first zone is the formation zone. So various control structures we make on those controls, on those formation zone. Like these are some of the control structures which has been placed in the higher reaches of Ladakh area, and in Uttarakhand area. Himachal also, we have put this type of structures to control it at the formation zone itself. So once the avalanche starts, major portion of the snowpack will be stopped at this level, and only a few can go down. So it will not create a major problem on the road access along those avalanche tracks. In middle zone, generally we construct the snow galleries and all. Like this picture you see, the larger picture will come in my slide also. Here, this one is the avalanche path, and we have made a snow gallery so that the vehicles can pass through this area. And in the runout zone, generally the control structures are in the form of wedges or side walls, and you can see it in the Badrinath area also. From the Badrinath, if you see towards the western side, you can find these type of structures we have created in those areas also. Apart from these control structures, once the condition is ripe and the movement we cannot stop, we have to move our troops in that area, then we try to artificially trigger the avalanches. So we don't wait for that critical condition when the avalanche naturally can come. Before movement of the troops, we trigger it, and triggering can be done either by firing from a handheld mechanism, or we drop the little explosives using the UAVs. And we have placed at few locations this avalanche detection radars. So the moment it starts from the formation zone, it gives a warning to the camp which is nearby that avalanche path, and they get sufficient time to move out from those avalanche zones. This particular slide I am showing is from the Sikkim area where we have put this avalanche detection radar. In the down below, it's a video wherein the explosive, we have put it in the UAV. It is being carried to the formation zone of the avalanche, and there we drop it and it triggers the avalanches. Apart from this, as we are measuring in the lab, those cracks and all, when it starts in the different metamorphosis conditions, and we have put the infra sound sensors in those hilly areas where the chances of avalanches are more, and based on the observation, the crack starts giving sounds, we give the warning of on both the edges of the road axis, so that the vehicle, if it is in between that avalanche path, can easily move out from that zone. And if the other vehicle which is about to enter in that avalanche zone, it should stop at that location itself. Apart from these, we are working on the avalanche victim search and rescue. Right now we don't have that particular sensor. We have purchased it, but now we are developing it with the help of our lab, and we are developing harmonic radar detectors and passive RF tags. So the soldiers who is entering in that zone will wear a tag on his hand, and if somehow he is trapped inside those avalanches, then with this harmonic radar, we can detect his presence, and the chances of his survival is more. This we are trying on certain major road access. As I said, we are giving the early warning and alert based on all these parameters, whatever I have said, based on the development of cracks, initiation of avalanche, and we stop the vehicular movement. This particularly has been tried on the Zozila axis, and based on our prediction and these measurements on the ground, we are saving the lives along those road axes. This is my last slide. This what I was showing there. I am standing on an avalanche site. Avalanche has occurred in that area, but it has not created any problem. As on the right side, you can see this snow gallery we have created for the movement of the people. The avalanche passes on the top, from the top of these galleries, and goes down in the valley. This has been constructed just before the Atal tunnel in Himachal, and this we name as MSP7. So before the tunnel, there are 12 avalanche sites. This is particularly on the avalanche site number 7. And if you want to know in detail about what are these, how these studies are being done, and what are the avalanches problem in those hilly terrain, and how we are making the different control structures and all, you can go, you can search this particularly in Google. There is a specific episode on our lab of half an hour, wherein we have discussed it in detail about the snow and avalanches. The website I have given. So anybody who wants, he can go and look for those 30 minutes presentation sort of thing, a discussion with the interviewer Pallav Bagla. That's all from my side. Thank you very much.
Okay, thank you, Dr. Lokesh Sinha. So it was a very nice talk, really. But I think any questions from the audience? But we are too late to give you some more spaces. Any questions from the audience? Okay, once again, thank you, Dr. Lokesh Sinha.
Thank you very much. How to unshare it now?
Just maybe close your mobile.
Okay, stop sharing.
It's not possible. Just unshare it. There is a okay. Thank you. Okay.
Thank you for giving me an opportunity to discuss it in front of the August gathering. Thank you.
Okay, sir. Welcome, sir. Dr. Asalata Singh. Kindly.
Yes, sir.
Kindly share your views. Dr.
Yes, sir.
Asalata Singh.
Yes, sir.
She is from the Department of Botany, Banaras University, Varanasi. So some special interactions for the decolorization and the degradation of reactive yellow 145 azo dye with bacteria. So what is the implication of the environment and the health hazards? Please share your views.
Yes, sir.
Where is your file on the desktop? Okay, full view.
Full view.
Go to the downside, right hand side, down, down, little bit down, down, down.
Okay. Okay. Okay, sir.
Right. One more right. One more right.
One more, right?
One
One
more.
more.
Click this one. Okay, click it.
Click it.
Okay. A little bit slow. It's okay. Network issue. Some net problem.
Oh.
Okay.
So my topic is problem.
It's okay.
Okay. ये क्या हो जा रहा है ये सब? What is? My topic is decolorization and degradation of reactive yellow 145 azo dye with bacteria. Implication on environment and health hazard. So, as we know that industrial growth leads to introduction of toxic chemicals and metals in the environment and causing environmental pollution. And we know that more than 0.7 million tons of synthetic dyes are annually produced globally, and nearly 10,000 dyes and pigments are used in various industries. In India, around 80,000 tons of dye and pigments are produced, which are dominantly used in textile industry. And a large amount dye effluent are generated by textile industry, which move through wastewater and cause environmental hazard. Dye color results into interference in penetration of light, affecting the photosynthetic activities of aquatic flora. And the mutagenic and carcinogenic xenobiotic chemical present in dye adversely affect the aquatic and human life. We know, sir, that when they are using this dye actually, so they just go through surface drainage and or just they dump in some sewer system. So it again it will move in nearby river, pond, lakes, and it contaminated. So it's having a various type of hazardous chemicals, having metals, having organic compounds, and lot of color is there. So that's why its removal is very important, because if it is moving in water, so what will happen initially, it will affect the photosynthetic activity of phytoplankton, so they will die. And ultimately what will happen when then these phytoplanktons will die in water bodies, so there will be deficiency of oxygen, and due to deficiency of oxygen, whatever aerobic microorganisms are growing in that condition, that will also die. So it will create an anaerobic condition, and under anaerobic condition, anaerobic microbes will flourish and they will produce lot of toxic compounds. So when there is a this water, it will move towards eutrophication, means it will such contaminated water, such toxic water, because under anaerobic condition, lot of intermediate compounds, organic compounds, it will come in the water. So even that water cannot be used for irrigation purpose also. So that's why its removal is very important, because if we are removing it, then only after this treatment only we should dispose it in any water body. So we have a number of physico-chemical methods already available for its removal of color, for degradation of textile effluent, its removal of metals, whatever it is present in dye, or organic compounds, those are present. Of course, physico-chemical methods are available, but if we are going through this method, means removing one chemical and putting another chemical is not good for water system. So that's why there is a need of some eco-friendly tools. And we know that this microbial tools is the best nowadays for removal of color and for degradation of organic compounds and for removal of metals and all whatever it is toxicity is present in dye effluent. So what we do, first we isolate different type of microorganisms, as here I am going to show in slide. So after growing this microorganism, we grow it in a mixture, in the nutrient media, as I'm going to show here. So we do the mass cultivation, and later on we use this biomass of microorganism in a different way, in the form of free cells or in the form of immobilized, and we treat the dye effluent. So in this study, actually, we have used bacterial consortium and to decolorize and degrade reactive yellow 145 azo dye. And this mixed consortium is a 10% amount concentration. It was efficient for 98.78% decolorization of reactive yellow 145 dye under static aerobic condition at 500 mg per liter concentration at 35 degrees centigrade and pH 7 at 12-hour contact period. And this is about decolorization and its degradation. Of course, it's having a lot of organic compound, and its degradation is also, in its mineralization is also important to get toxic free water. So I have gone through analysis of FTIR analysis and UV visible analysis. So here, this is the result, what I am showing here. We have used the mixed bacterial consortia at pH 7. It was able to remove maximum color. It was able to decolorize this wastewater, and in presence of two types of media, that is nutrient broth media and GPY media, but nutrient broth was best for decolorization in 12-hour incubation period. And the same, through same mixed consortia, I have prepared its beads also and free cells also and used it for decolorization. We got it that free cells was more good, more efficient for removal of color. And so that's why for further study, we have used free cells of this mixed consortia instead of beads one. Different parameters we have used, because see, microbes, those are working for decolorization and degradation of dye. Actually, all these work happens due to presence of certain enzymes, and enzymes, it function, it work at particular temperature, at particular you can say nutrient at in favorable concentration of salt. So that's why here we have seen temperature that was optimal 35 degrees centigrade, and at this temperature we got maximum removal of color. And here we have seen this inoculum size 10% and more than 10% if we are using these microbes. So they have a computation, and so that's why degradation, it will become slower. And this dye itself act as a carbon source, so control was the best for the decolorization process of dye. And this here I have used nitrogen source, and this ammonium sulfate was the best for decolorization of this dye. And salt 1%, it was good for maximum decolorization. And if we are increasing the concentration, because our organism, we are optimizing all these things in our laboratory, and we see how much capacity of this microorganism for decolorization and degradation of this compound. So we got it that if we are proceeding more than 500 mg per liter, then again there is a it is not efficient for decolorization and degradation. And later, so again we have used this consortium treated and untreated reactive azo dye. It's the absorption spectra 200 to 800 nanometer, and have seen that if you are not treating this dye, so it's having this kind of peak it's having, and its peak, this peak, it indicates the azo bond. And when we are treating with this dye with the help of micros, with the help of consortia, so there is a absence of this azo bond. It means there is a breakdown of this chemical compound, only not only decolorization of dye. So the same thing it is given here about this breakdown of azo bond and degradation. And again, for this, we want to get it confirmed about this degradation of this dye, because it's having a different type of organic toxic compounds, and they are very harmful for human being, because if we are not treating dye properly, and it is going in some water bodies. Again, we are using that water for irrigation, and also through food chain and food web, it will reach up to us and will create number of diseases. So that's why degradation of this organic compound is also very important. So for that, we have gone through FTIR analysis and have seen that this is the control one of dye and this is treated one, and if we compare it, we see it. So there is a less number of peaks, and all functional group, we will see there is a change in functional groups, and number of peaks are also lesser in number. And so these are the proof of that these microorganisms are very efficient for decolorization, for removal of color, and for degradation of toxic compounds. Those are present in dye. So after treatment, of course, we can use the same thing. It is given here. This is the chart. It is showing the functional group and peaks and bonds, whatever change we have got in treated and untreated, and it's give evidence that bacteria is efficient for degradation and for decolorization of various dye effluent. Same thing it is given. So I want to conclude it that this bacterial technology, of course, is very good for treatment of wastewater, either it's having a dye or color, any type of color, or color due to dye, or due to in dye effluent, whatever organic compounds degradation can be done. So with the help of microorganisms, with the help of this bacterial tools, because it's very cheaper and less time taking, so we can use this tool for the removal of toxic compound, for treatment of wastewater, and after treatment, these water can be used, it can be recycled, can be reused in industry. To at the same time, we can save that much amount of clean water. I think this technology is nowadays is the best, and we should go through it. Number of, we know that in every city there is a sewage treatment plant, but I think they are not going through this. And if we go through such technology, so definitely we can get clean water, and later on it can be dumped somewhere, or it can be reused at site only. Thanks a lot. If any question, please. Welcome for your questions.
Thanks, Dr. Asalataji, for such nice talk. Any questions from the audience, please? Please unshare your slides. Okay, thank you. So the next talk is by Professor S.C. Bhatt, my colleagues, on the land of soil degradation in Bundelkhand regions using GIS and Russell methods. So Asalataji, please unshare your. Okay, I will help to the.
Okay, thank you. Can we take this full screen? Okay. Good afternoon. The topic of our talk is assessment of this soil erosion, land degradation in Bundelkhand region, Central India, using this GIS, geographical information system, and host method. So, yeah. So before going in detail, we can see the status of the land hazards and global, which are happening globally, and Indian status we can see. And if you see the disasters, the frequency of disasters, they have been increased, and they were higher, that is 30% higher. But if you see the death rates, that the mortality has decreased since 2021. And you see there are 115 people are dying since the last 50 years. And the loss of the property can be estimated that is $202 million per day. And the global deaths, which are 45,000 to 60,000 people are dying. And the rate of this global death due to these natural hazards, that is 0.1%. And the most fatal events which were happening, they were the drought and floods. And the most deadly, these are the earthquakes. And if you see the Indian status and the scenario, we can see the death casualties, they are more than 200 people they have killed due to these natural extreme events, and all over the India. That is, if we see, we have already listened the talks of the previous speakers, the Sundaryal and the Professor Sundaryal and Professor Dubey. And due to the extreme weather conditions, you see there were the flash flood, and you can see the incident of the Rishi Ganga, which were happened earlier. So in 2021, you can see the 432 catastrophic events were recorded in India, which were more higher, and the average 357, and since 2001 to 2020. And among these events, the floods were quite dominating. And you can see there are 223 occurrences. And you can see the monsoon too in 2021. The India experienced the most serious deadly floods. So now we can come to this location, the Bundelkhand region of the central India. You see in central India, basically, particularly this Bundelkhand, it is having, there are 7 districts in the Uttar Pradesh and 6 in the MP. And this whole region is called Bundelkhand. And it is basically a plateau region, and there are dry conditions are there, semi-arid conditions are there. And you see if we can see the rivers which are flowing, and in this region, basically the most of the river, there are 3 and 4 rivers which are also called cratonic rivers. And these rivers, the Ken River, Dasan River, Betwa and Sindh, they are originating from the Vindhyans ranges on the granitic terrain, and then they are meeting to Yamuna, which is one of the major river system of the Gangetic system. So look here, you can see it is a high relief terrain is here. And so these terrain, they are mostly dominated by this gully erosion. So we have used the SRTM data, and then we have did the morphometric analysis, tectonic analysis, and then prepared the drainage maps of the rivers. And here you can see these are the Dasan River. It is one of the tributary of this Betwa River. There is a Bahupahud River. There is a Jamani, Ken, and Sindh rivers. All these rivers, they are showing these, mostly the 5 to 6 order of drainage pattern, and most of these drainage patterns, they are characterized by dendritic to subdendritic pattern is there. And all these rivers, you can see, they are mostly elongated, which are indicating that these rivers they are controlled by these structural features and the homogeneous lithological characters. So if you see the status of land and rainfall, there are in India, the degraded land. Yes. Yeah, actually. Okay. And the status of land and rainfall in India.
Yeah, the slide is not.
बढ़ी नहीं.
And
Slide बढ़ी नहीं.
Nagar Dubaji.
हाँ, अभी बढ़ नहीं रही.
Can you see the slides? What is?
Yeah, but it is not moving.
It is not moving. That's the problem. What is the problem?
Okay.
It is on first slide only.
Only the first slides.
Yes.
The whiteboard को बना रखा आपने. Where the file? Just wait few minutes. Where the file?
File in desktop.
Where is the desktop?
You just minimize it and then see. Yeah.
No response.
This is.
ये तो abstract दिखा रहा है.
No. This is. This presentation. It's okay now.
No. हाँ, अभी तो ठीक है. Now it's okay. Now it's okay. Yeah, first, second.
Okay.
Yeah, it works now.
It's okay now. It's okay.
Yeah. Okay.
Third one, then.
Yeah. Now it's okay. Now it is moving.
Okay. Thank you. If you see the status of these land and the rainfall pattern in India, you see there are the graded land is total, that is 329 million hectares, and that is about 40% on the land which is degraded in 103 districts out of 16 states, and they were adversely affected due to drought. India experienced that is 47% of rainfall deficit. In South India, 30%, in Northwest India, 18% in Central India. This was the IMD report and the Indian Meteorological Department report, which has given in 2019. And if you look the Bundelkhand, you see it is again, it falls into semi-arid regions, and the rainfall is less than 800 millimeter. And it is a dry land, as I have already said, and it has only a small cropland, that is 30 to 40% is cropland still. And the population is here, that is 18.3 millions, and the 79% of people, they are living in such a drought affected areas. And the rainfall pattern, again, I have shown earlier, that is 800 to 900 millimeters, and which affects the productivity and soil moisture and socioeconomic growth. And the rainfall during the monsoon, it occurred, 91% of the total rainfall occurred during the monsoon. And you see there is a declination of the rainfall, which occurred, that is in 2004 to 2007. And eventually there was a drought, and the meteorological drought, the hydrological, as well as the meteorological hydrological drought that has occurred. And deficit in 2004, that is the rain, it has 24%, which has increased up to 56% in 2007. If you look this diagram, you can see and the rainfall pattern, which has suddenly declined, and if from 1995, and then it was, you can see here in 2004 to 2007, it has declined up to 400 millimeters. And eventually it was the drought here. And you see again the status of the soil loss. And globally, you see the 2 billion hectares land, that is 1,100 MHA land, was affected by water erosion, or 550, that is by wind erosion. Since if we see since the end of the World War II, about 85% land degraded due to soil erosion, and it caused 17% of reduction in crop productivity. And 30% of, you see, the world's arable land has become unproductive, and due to the erosion over the last 40 years. So if we see the soil loss in India, the about 119.2 million hectare land was affected by soil erosion. The average annual rate of soil erosion, that is 16.35 tons per hectare, and the 45%, you can see, land of the total geographical area was affected by the soil erosion. So if we see the scenario in the central India of Bundelkhand, it has the total land resources. They are 38,000 square kilometer area, and the most of the, you see, the 60% area, it was covered by the granitic hills. And the agricultural cultivated land is here only 4 million hectare area, and that is the 50% is net sown area is here, and the 7% is cultivated wasteland is here. So wasteland, barren land, approximately it covers the 11,000 square kilometer area. So Bundelkhand, it is, as I have already mentioned, it is a zone of semi-arid. It belongs to the semi-arid climatic zone, and the rainfall, that is below 800 millimeters. And the gully erosion is more dominant, and here, particularly in the catchment areas, which I have shown in the river system, and the 11,000 square kilometer area, which was affected due to this gully erosion. So 0.5% of Bundelkhand was affected by this gully erosion. So we have used this loosely method, and if there are factors, basically the rainfall erosivity factors, the soil erodibility factors, that is K factor, slope length factor, steepness factor, which is called LS factor, and the crop cover management factor. We have considered these factors, and then this is basically the revised universal soil loss equation, and then the soil loss of the total area has been estimated, and that is the A is equal to R into K, LS, and C and P. So you can see here these maps, which were produced by these thematic maps. They have been produced with the help of GIS, and you can see there are the R factor maps, that is the impact of this rainfall that is on the soil and on the landscape, and then we can estimate, and it is estimated for this Bahudjit basin. The river is here, which is also one of the tributary of this Sindh river, and you can see this R factor is more in the catchment area from where the river is emerging, and it is declining, emitting in here in the large area where the river is meeting to the and it is to Sindh or Gangetic plains. So if you see the rainfall pattern in this region, you can see again it is quite higher in the highest ranges from where the river is emerging, and it is low in this granitic terrain. Similarly, we have also prepared estimated the R factors and rainfall pattern for the Kane basin. Kane is also one of the important basins of this. It is the Yamuna river, And this is also a cratonic river, and you see here also the R factor, and it is less in the. You can see here it is less here, and in these areas where the river is meeting, and it is maximum here from where the river is emerging. And all these rivers in the Bundelkhand, they are originating from the southward and then flowing in the north sides. And this is the rainfall patterns here, and the maximum rainfall pattern again, which is estimated in the where from in the catchment area, you can see here, and then the minimum is in the lower basins. So on the basis of this method, we have estimated the total soil loss, and this soil loss, annual soil loss, you can see, for example, for this Pavoj River basin, and it is quite low, and it is represented here by yellow color. You can see the large area which is shown by the yellow color, that is quite less. That is only the 0.01 ton hectare per year. And the red is shown, it is maximum, that is the 16.3 ton hectare per year. So, and these two types of soils are dominating here. This is the trick Cambi soils and chromic Luby soils are here. So similarly, again, for Methane River, you can see there are two types of soil are again here, chromic Luby soils and chromic vertisols are there. Again, this yellow area, which is showing the low soil loss, and the higher soil loss can be represented by this here, which is the whole area, which is showing the erosivity and the erosion is quite low in these basins. So the land cover pattern you can see here. So although the cropland you can see here, the cropland is more dominant here, and this which is represented by the green color in this Pavoj basin, and in the Cane basin you can see again the cropland is more dominant. So there are, and the water bodies are very less. The settlement areas can see here, you can see here, and the barren land is quite less. So based on these methods of the data, we can conclude that basically the R factor in the rainfall, the pattern Pavoj and Cane basins indicate that the catchment of the basin, it is showing the higher intensity and rainfall than the middle and lower parts of the basin. And this rainfall erosivity, R factor and decay factors, topographic factors, crop management factors, infer that the low to moderate erosion severity is observed, and this loss of soil is low to moderate. The average rainfall, as I have mentioned earlier, it is below 800 mm, and low relief, low vegetation cover, and poor land management imply that the area is represented by the low rate of the soil loss, sediments transportation. So you see, we are also seeing we are working on the groundwater potential and also on this validation of this data by the sediment SDR values. We have to estimate the sediment loss values also. So the low value and the ruggedness value on the basis of morphological data, we can imply that the basin is also moderately rugged, debris, watershed, and less prone to erosion. And these practices of water and soil conservation will enhance the water storage capacity. If these practices and the key factor, the practices they may be increased, then they can prevent the soil and sediment loss in such drought-affected areas. And these research findings, they may be helpful in management of the soil loss and watershed management. So this is all about my from my side, and thank you very much. Thank you, Vinod. Okay.
Stop share.
Okay.
Okay, so thank you everyone. Are you listening my voice?
Yes, sir, you are audible.
Yes, you are clear.
Okay, Bhasan. Why you put of you? Bharji, can you close your audio? It's okay. Not problem. Please. Okay, so please, maybe it's fine. Okay, so any questions from the audience on Bhatt's presentations? This one is clear to all of you. Okay, please. Then Dr. Sharda Prasad Pradhan, are you ready? Dr. Sharda Prasad Pradhan. Okay, so his topic is the investigation of a landslides in Uttarakhand, Himalaya. Dr. Sharda Prasad Pradhan.
Am I audible, right?
Earth Science, IIT Roorkee.
Am I audible?
Yes.
Yes.
Yeah. So good afternoon all. I'll be talking about investigation of a landslide and its mitigation measures that we have done recently in Chamoli district of Uttarakhand. So we know that the landslide is a natural hazard that affects life and economics and environment, right? Mainly in mountainous region, that too particularly in Himalayan region, Western Ghat and Eastern Ghat region. So similarly, one landslide that occurred near Gopeshwar, right? Because the time is 10 minutes, so I will wrap up within 8 minutes, I think so. So this is the geological map of that region, and the rock type that we encountered over there is schist, phyllite, and quartzite. And we can see a few photographs of this landslides there. This is Gopeshwar town, and this is the landslide part, this part. So a linear, you can see the linear mark here, that is the landslide part here. So when we investigated, we observed that there are many debris which are on this slope, right? So initially we thought it to be a debris slope and debris failure. Then we reached down to the slope and we found some rocks there, right? Those are phyllitic rock. So it's a, I will say, a complex type of slide. And just above the ground, we can see there are many residential buildings are there. And this is the crown of the landslide, which is situated just at the foot of the residential building. And above this residential building, we have a road, then there is a slope break, then again we have a slope. So because of this sliding, the slope mass above this road and below this road, there are many cracks on the houses, many cracks on this road as well. So we try to give the stabilization measures for this particular landslides there. So we have measured, okay, initially we thought it to be a debris slide, as I told you. Then later we found these are the rocks that is phyllitic rocks that is exposed at that point. So we have taken the sample, we have tested it, okay. We have characterized the rock mass, their foliation, what are the joints and how they are oriented, and whether this is structurally controlled landslide or not. So that we need to investigate whether this is simply a debris failure, that the debris that is resting over this, has moved down, or it's both rock and debris. Then to ascertain this, we did ERT study, and we found, okay, there are debris at the ground portion. Then we have some rock exposure here. Then we have debris, right? Again rock. So approximately 15 to 20 meter of, we'll say, debris and weather rock material is there. And then we have bedrock, right? And these debris are quite saturated because, as I told you, that there are many houses, residential houses and buildings are there. So the water that may ingress into the slope and has deteriorated the slope mass there. So our aim is to stabilize this debris, stabilize the rock, and make some reclamation measure at the ground so that it will remain safe. So we have conducted slope stability analysis. So we have done various rock mass characterization, RMR and GSI, and we got, okay, the RMR is very low, 25, GSI is also around 35, so rock mass is poor. And we have done this kinematic analysis, and we found there are chances of wedge failure there. As I told you, there are foliation plane and joints, and these foliation plane and joints, they intersect with each other, and many wedges are forming, and those wedges might have slipped. And when those wedges slipped, it took the entire debris over it, and there was a landslide. So different scenarios were simulated, right? So we have taken, because this is we have done the postmortem analysis, and we have to stabilize the present slope. So what we did is we have taken the slope profile, we have taken the total stations, and we have made generated EM. From that, we have made this profile. Then, as per our data, the field data, geotechnical data, and the EIT data, we then build this model in rock science software. Right. So we have a debris, then we have a weather rock, then we have bedrock. So three conditions were simulated. One is in unsaturated condition. Let's see what is happening. In unsaturated condition, you can see that this layer there is displacement. So we need to stabilize this. And once there is ingression of water into this, then the displacement is moving towards this, and there is a debris and rock, both you can see the displacement maximum, right? Then in seismic condition, you can see the entire thing from this to this, and the factor of safety is coming less than 1, so it becomes very unstable, right? So what we did, we have proposed remedial measures plan for this one, because houses are there, the landslide is the ground part of the landslide at this point, and it goes up to this around, I will say, 150 meters, right? So as the houses are here, we need to stabilize the house. There should be no movement at this point. So we put micropile here, okay, and we have inserted the self-drilling anchor here, so that this portion, particularly the crown will remain safe. And to reclaim this area, because at the just below this house, there are the ground is there, so we need to stabilize this ground, and it should be reclaimed so that a sense of safety should be there. So we put a MSE wall here, and this micropile, over the micropile we have a MSE wall, then we have put this SDA. This is in our proposal. Again, as I told you, that once we move to this, we have this road section, and above road we have different buildings, different houses, and slopes are there. So this needs to be protected, because once we protect this, then there may be movement at this part, because there is a slope, there is a flat a bench, that is the road, then you have slope here. So you put another micropile layer, which will register deformations in this directions, right? So we have two micropile layer and one SDA here. Then, as we have seen that the deformation was here from this part to up to this debris which is deposited here. So there is the most of the deformation is occurring at this point, as the simulation result shows. So we put anchors here. While we put any anchors, we have
make alternate arrangement of their length, means someone is 12 meters, someone is 9 meters, and that gives extra stability to this mass. So this is our aim. Then at the end, we have debris, right? For this debris, we propose a cantilever wall so that this mass will be retained. There will be backfilling and there will be 6 meter height cantilever wall. So this is the entire plan for this to stabilize. So in nutshell, I will say we have done geological study, we have done geotechnical and geophysical study. Then we simulate these conditions, okay? After getting the inputs from our lab and field, then we simulated the slope and different scenarios were considered, and accordingly the remedial measures were taken. So if you see, if in a contour map, we can see we have a road here, we have those micropiles section we have put here, 20 meter micropiles, the depth of the micropile is 20 meter, then another micropile layer at the crown of the slope. This green part is your landslide mass, right? Then at the mid we have a cantilever wall. At the end we are putting a gravity wall, right? This is very important because this is there are numerous houses, the residential buildings are there. So we have seen there are many fractures. So we need to stabilize this landslide as well as these sections. So this micropile layer was inserted there. After you can see this scenario, after putting this support, we have seen that there is an increase in the factor of safety. You can see the increase in factor of safety. This is 1.66. Then with 4 pressure, this is 1.48. Even during this seismic loading conditions, the factor of safety is coming more than 1. So we can see without support and with support. So even if seismic conditions, the support measures that we have provided, that will remain stable, and there will be stability in the slope mass. So this is the schematic view that we have done, that MAC wall I talked about. This is the micropile. Above this we have put the MAC wall so that, and we'll fill it so that this mass can be reclaimed. So this is our design plan. So this is a typical mitigation measures that we have conducted in Himalayan, in many Chamoli district near Gopeshwar town, right? So there are many causes. I know there are natural as well as anthropogenic causes, okay? And from investigation we need to do the mitigation, because more and more infrastructure development will be there, more road construction will be there. So this needs a proper mitigation measure so that the slope will remain stable and our development will go on. So thank you very much. So if you have any question, please, I would like to answer if you have any question.
Hello. Good evening, sir.
Yeah.
Sir, you have said that you have put some micropiles on the hazard area to stabilize the land, these landslide prone areas. So my question is that you have how much you can reduce the hazards of these landslides from these techniques? Is there
how much?
How much, sir, capacity of these microfiles to reduce these landslides hazards?
Yeah, that depends upon the slide mass and rock mass and what is the stress that is acting over there. Somewhere we can put piles also, okay. But if you have limited area where the access is very less and putting pile is difficult, micropile does good work, right? So we have chosen that because in that you have a road section, there are many buildings, and particularly in this region, in that part, the area where we can construct anything is very less, right? And that's why we have taken this micropile.
Okay, sir. Thank you very much.
In the stresses, everything is calculated. What is the actual loading will be there? What is the bending moment? That has also been calculated in okay, it is safe.
Is my voice is coming?
Yeah, it's coming. And,
okay,
and I hope I saved your time.
Okay, so once again, thank you very much. I think I request Dr. Nageshwar Dubey. So he has to go somewhere in the meeting. So I request Nageshwar Dubey. Piyush, your lecture will be after Nageswar.
Okay,
Then
sir.
his topic, Nageswar Dubey, please.
Yes.
Share your slide, please. Okay. So he is from the Department of Geology. Addis Ababa, Science and Technology University, Ethiopia, Northeast Africa. His topic is the vertical discontinuity of thick succession in triggering the landslides of the Blue Nile Valley of Ethiopia. It's okay, sir?
Yes.
Okay. Share it, you will see the share,
Yeah.
and then no, open where is the desktop?
Desktop is open.
Okay, then
I tried the share
it, and then full view.
Yeah, full view. Is it sharing?
No. Just okay. Just go to where is your mouse? Downside your mouse. You should. Okay. Now down little bit downside. But share it in a full screen. No. This is. नगर सर जी, आप माउस को वहीं नीचे करिए.
अच्छा.
और यहाँ पर एक व्यू बना हुआ है, फुल व्यू. नहीं है. Where is your mouse? F5 कीजिए जरा, तो F5.
अभी हमारे तो ठीक दिखा रहा है.
नहीं, आपका ठीक नहीं कर रहा. इसमें भी आप जरा इसका माउस इसके ऊपर हिलाइए तो मैं बताता हूँ आपको. हाँ, okay. Just wait. Now go to the downside. Down. Okay, down little bit. Left. This icon. Left. Not too much. Very fast. Go to downside. Down. Vertically down. And now click it. Click. Okay.
ठीक है.
Okay, ठीक है. Now you continue, please.
First of all, I would like to thank Professor Vinod and Professor Ramatar for giving me this opportunity for third time, because they are regularly taking pain and they are organizing this seminar every year. So this is one of the view of the field from where my observations and data they are collected. This is the panoramic view of Blue Nile, Nil Nadi. So Blue Nile is flowing somewhere here. You can see just behind me. This is the Blue Nile Valley running from right hand to left hand side. And if you assume this valley, V-shaped valley, very deep, almost 1.5 kilometer deep, on the surface, ground distance will be around about 10 kilometers. So within 10 kilometer surface distance on the ground, 1.5 kilometer deep valley is there. And in this deep valley, top portion is covered by basaltic lava magma, and bottom is unexposed basement granitic rock. But in between the sequences, which are representing in this valley section, they are Paleozoic to Mesozoic, and like our Gondwana, Lower Gondwana, and Jurassic Cretaceous of India. So this is one very generalized geological map published by Ethiopian Ministry of Mines. Here you can see there are many basins. This one is Mekelle Basin of Ethiopia. This one is Gambela Basin. My study area is this one, Nil Nadi, Ethiopian Nil Nadi, or Blue Nile of Ethiopia, which is very near to the capital Addis Ababa. Other basins are also there, particularly this Ogaden Basin, South Rift Basin, and Matema Basin. So these are the common basins of Ethiopian subcontinent. This is the general geological map of the area. Here, more interesting thing is, as you know, one 3-arm structure of geology. One arm is this one, Red Sea. Red Sea is one arm. second arm is Gulf of Aden, and the third arm, it is going inside the country, and it is known as East African Rift Valley system. So East African Rift Valley is also passing from this place, Djibouti, to Ethiopia, to Kenya, and it is going towards Uganda. So this is the general geological map of the area. Our study is confined somewhere here. So this river, which is written as Abay, Abay is the local name given to the Blue Nile River in this region. So village people, they call it Abay River, whereas internationally the river is called as Blue Nile. So in this diagram, the rifting is more clear. One arm, as you can see, Red Sea. Another arm is the Gulf of Aden, and the third arm, it is on the continent, which is very active, and we call it Rift Valley. So this is the general geological succession of the area. Let us go from the top because it will be easy. So on the top, you can see pile of lava flow. Almost 400, 500 meter thick lava flow is there, but many layers are there. We call it traps. So there are many traps. In between the traps, intertrapian beds are also there. So in between the lava flow, whenever there is cool and calm period, sedimentary basins, smaller size lake, lagoon, they also develop. And within that lake region, river region, some coal deposits are also buried in between the lava traps. So thickness is not very much, maximum 2 meter, 3 meter thickness. Lignitic variety of coal is also found, but within the intertrapian. So this is the story of the top. Just below that, you can get the sandstone, which is of lower Cretaceous age, like our Bhuj sandstone of Kutch. Below that, you may get a thick succession, almost a kilometer thick succession is locally, they call it Antalo limestone, like our Patcham limestone, Chari limestone, Dosaulite. So they are very similar like that. But these limestones, sometimes they are thick, sometimes they are thin, but they have always intercalations and alternate layerings of marl, calcareous cells, and limestones. Below that horizon, you will get a thick sandstone horizon. So this is Adigrad sandstone. Roughly, it is Triassic in age. So this part is Triassic. This one is Jurassic. This one is Cretaceous, and above the Cretaceous is the end of Cretaceous or beginning of the Tertiary. Paleogene age basaltic rocks. And if you come just below the Mesozoics, you will get the Gondwana sediments. So this Gondwana sediment, it represents Telites, pure glacial deposits. Sandstones, when the glacials melted and they produced the alluvial system. So fluvial sandstones and glacial Telites. In between, if a lake was there, in that lake, you may get mudstones deposited in the lake. And in that lake, if any glacier is reaching, that may drop the big size boulders of granites, metamorphic rocks, 2 meter, 3 meter in diameter. So this part represents lake deposits with drop stones. And this is Paleozoic deposit. Below that, again, unconformity. And this is the Precambrian part of the area. So this is the general geological map of the area. This is the model concept. If you see this side, Somalia, Kenya, Ethiopia, Eritrea, Sudan. So in a regional basis, like a sequence stratigraphy, sea was in the eastern side, southeastern side. It has gone in this direction, kilometers and kilometers. So when the sea has gone this side, transgression has taken place. When the sea has gone back, regression has taken place. So in Triassic, Cretaceous time, transgressive, regressive deposits are there. Below that, these patches, they are Paleozoic deposits like our Gondwana, and below that is the basement rock like our granitic basements. This is the field photograph of the area. First slide of my presentation. You can see here on the top, there are many basaltic traps, thick lava flows with intertrapian. And below that, you are getting upper cliff limestone. So why cliff? Because the beds are very thick and they have vertical joints. So cliff forming escarpment or cliff, very high cliffs are there. Just below that is limestone gypsum succession. And then second cliff limestone is there, and second gypsum is there. And just below the second gypsum is glauconatic mudstone. In sedimentary, whenever we get primary glauconite, we are sure that glauconite is the mineral which originates only in the sedimentary marine environment. So glauconite is appearing here, means marine environment has started. Then gypsum limestone, and on the top lava flow is there. So this is transgressive, regressive deposit of the Ethiopia. Below that is the Adigrat sandstone. In this sandstone, it looks very hard, very compact like our Bindhan sandstones, but it has big size wood blocks, fossilized wood trunks, 10 meter, 20 meter long wood trunks are there. Many people assume it fluvial, non-marine. Many people, they call it marine, but it has more influence of marine. And below that, there are patches of Paleozoic deposits like our Gondwana, in which you may get boulders, tillites, and some sandstones, fluvial. So this is the basalt. You can imagine this is a tree of Bargad people, banyan tree. And when these blocks were intact, along the joints, roots of that banyan tree has gone below. But when the block is moved from there, roots are naked. You can see the root system. So you can imagine how thick is the succession. And when such boulders, they are rolling on the bottom of the cliff, they are the main hazards in the rainy season of this valley in the upper part. So my topic of discussion is vertical discontinuities. If the horizons are massive, if there is no structure, there will be no problem. But they have vertical discontinuities, and in the lava, generally the vertical discontinuities, like our columnar joints, they are the cooling surfaces. When the material is cooling, when the volume is reduced, then vertical joints, they develop and they go below, like mud cracks in the sedimentary environment, so tapering down. So such thick blocks are there, and these blocks are one region of landslide. And coming to down, this is the intertrapian, where you can see the sedimentary deposits. Below also is the lava, above also is the lava, but in between is the thick, few meter, 2 meter, 3 meter, 5 meter thick horizon intertrapians. Here you can see this is a basaltic material, but here you can see columnar joint. Can you see this columnar joint? It has a trend of top to bottom in this direction, but another columnar joint is here and it is moving in this direction. Can you see it? So there are two orientation of columnar joints, vertical joints. If such joints, they are covered with soil, so civil engineering people, if they are not well equipped with this knowledge of vertical joints and cooling surfaces, if there is a road just below here, keeping in view that soil is there, so when the water will percolate the soil and when it will reach in this horizon, there are two sets. one set will move in this direction, another set will move in this direction, because this is the vertical discontinuity in the lithology. So vertical discontinuity should be taken into consideration. Here you can see the same lava, one set is in this direction, columnar joint, and another set is in this direction. So you can here see V notch of two sets of columnar joint in the same lava. So they develop because of the orientation of the cooling surfaces. So cooling surface on the top or on the sides or on the bottom. On the bottom, how cooling surface will be there? If it is a sill, then energy will be lost in the bottom also. So cooling surface is producing the joints. Here is the Antalo limestone. You can see pure limestone of cement grade, but they are very thick, but they are very hard. If you will try to hammer it, you will lose your hammer. Hammer will be broken, but limestone will not break. But it has also joints. So here you can see big joints, and along the joints, there is dissolution activity, cavities, crust, stalactite, stalagmites. So sometimes these blocks also, they move. And they move if there is gypsum, because during rainy time, gypsum behaves like a soap.
Conclude,
so it facilitates. Here you can see thick limestone, but in the thick limestone, there is chert. So this horizon is chert. This horizon is chert. So chert limestone, chert limestone, chert limestone. Geologically, it is very important, because if you test them in the field, limestone will react with acid, but chert will not react. What is the vice versa of this? When the limestone was produced, environment was not acidic. Otherwise, limestone will remain into liquid. So when limestone was precipitated, the pH was basic. So basic pH facilitated the limestone precipitation. But when chert is there, it is also the deposited material. During deposition of the chert, environment was acidic. So limestone is dissolved in acid, but it is not dissolved in base. So two environment, acidic environment, basic environment. So when we talk about acidic, basic, we talk about carbon dioxide, oxygen. When oxygen is more, oxic. When carbon dioxide is more, then acidic. So maybe in their deposition, environment has played very important. Here you can see thin limestones with cell, but these cells also, they react with acid. It means they have calcium carbonate content. So calcareous cells, they call it marl. Marl limestone, marl limestone, marl limestone. Two environments they are repeating in geology. Here you can see this one, thick one is gypsum, and this one is mudstone. Again gypsum, again mudstone. So two environments they are repeating: evaporatic environment and clastic material. Evaporatic, clastic. Here you can see these are glauconitic mudstones and limestones. So when glauconite is there, it gives clear indication of marine environment. Here you can see the Triassic sandstone. They are thick sand bodies with plant fossils, no animal body fossil. And in the upper part, they are very thick. But as you go down, their thickness is reduced, and then mudstone is also repeating. So lower part is mud dominated, but in upper part it is sand dominated. So two environments they are repeating again here. And this is the panoramic view of the river. This bridge is old bridge, which was used 10 years back, but now a new bridge is constructed. This is the Blue Nile River in the area. So from this point to this point, it is 10 kilometers on the map, but by road it is 40 kilometers. Zigzag road, because the deepness of the valley is 1.5 kilometer vertically, almost vertically. This is the sandstone, and they are very simply dipping towards away from the our side. They are dipping towards away, and here you can see the road. And this is the Blue Nile basin of Ethiopia. Here we have seen crocodile. From the bridge, you can see crocodiles also. But sometime we are coming up to this point to see the basement. The oldest rock is exposed in this region. So we generally with a student, we used to come up to this point with full safety and precaution. So this is the oldest exposure of the Blue Nile area, where you are getting the Gondwana equivalent sediments. They call it pre-Adigrad sandstones. So my conclusion is, study area is characterized by thick tertiary basalts, and they have the columnar joints, which are the product of cooling surfaces. And when there is weathering, if they are covered with soils, they can give a false impression, and sometimes they create very difficult situation for the road transport. And cliffs, escarpment bases, they are the landslide zone in Blue Nile basin, and below thick basalts, oolitic fossiliferous limestones are there. They have also vertical joints, and similarly, they have also the zones of hazards, thick gypsum and mudstones horizons also. They also facilitate sometimes the landslides, and thick sandstone unit of Triassic age also sometimes it creates the problem. So here, this is the last slide. You can see one columnar joint is horizontal. You can see it. I am sitting on that. This is natural. It is not man-made. Another columnar joint here you can see. Hexagonal, benzene ring-like structure. So this is my observation from the Blue Nile basin of Ethiopia, where vertical discontinuities, they facilitate the natural hazard, particularly landslides, mass movement in the Nile basin. So with this slide, my presentation is over. Thank you very much for giving opportunity and listening me patiently. Thank you.
Oh, thank you very much, Sir Professor Nageshwar Dubey, for a nice talk. I think we should conclude the session very quickly. So now I request Piyush to give your lecture with Sardar Prasad Pradhan from the IIT.
Yes, am I audible, sir?
Yes, yes. So please share your presentations. Influence of the
Yes,
geological structures in rock slope stability in a road cut section along National Highway 9, Kumai, Himalaya. Please share your slides.
yes, sir. Is it visible, sir?
It is visible, but share it. Where is your? Open it and share it.
I have shared it, sir. Is it visible?
No, no, no. You share it. Where it? Have you opened now the
Yes,
share
sir.
it?
Yes, sir. I
Share.
have opened it.
Your file, you have to open your file. Okay, now it is coming.
Okay.
Okay.
So,
very quick, please.
yes, sir. I'll not take much time.
Okay.
So, good afternoon, everyone. My name is Piyush Kumar Singh, and my talk is on influence of geological structures in rock slope stability in road cut section along NS09, Kumayu, Himalaya, India. So in this presentation, I'll be telling about the kinematic analysis and rock slope mass classification in which way I have classified the slopes present in my area on the basis of the joints as well as the different field parameters. So what is slope stability? Slope stability refers to the condition of inclined soil or rock slopes to withstand or undergo movement. It depends upon the geological as well as geotechnical characteristics of bedrock and soil that compose them. The structures in the rock slopes that affect their stability include tectonic joints, faults, bedding planes, foliations, etc. Since we all know that in mountain terrains of Himalaya, road and highway networks play a vital role in remote areas for transportation, public network, etc. The stability of these rock slopes along the roads and highways is a major concern in hilly areas. And since Uttarakhand is very prone to natural disasters and majorly landslides causes a huge loss of life and property in Uttarakhand district. So my this talk will be on NS09, which is present in the districts of Pithoragarh as well as in Champawat. So this is a geological map of the study area where the locations of the slopes that have been studied for their stability are marked. Along with the north Almora thrust that passes through the area, which is the cause of major instability in the area. So the geology of the area includes the Almora group, Jausa group, Ramgarh group, Damtha group, as well as Tejam group of lesser Himalayan metasedimentary zone, along with the North Almora thrust. So first of all, I'll be telling about the kinematic analysis which has been done in my area. Which has been done in different slopes to check out the type of slope failure, that whether it is a slope wedge failure or planar failure. The kinetic analysis is used to evaluate that whether blocks or masses of rock will move along geologic structures and slide out of the face of a slope. Kinetic analysis doesn't take into account the forces that cause the movement, but it is concerned with the direction of movement. Hook and Bray, in 1981, they noted different types of slope failures in kinetic analysis, which include toppling, wedge, planar, and rotational. So the toppling failure can be the wedge failure. Basically, the planar failure occurs when the joint plane is parallel, in the same direction of the slope. And the wedge failure forms due to the intersection of two joint planes, where the intersection, the plunge and trend of intersection is in the direction of slope dip direction. So this is the kinetic analysis of slope L1, which is showing the wedge failure as one critical wedge failure. This one is from the slope L2, which is showing one critical wedge failure. And also we saw the type of a toppling failure, which can be seen in the field observation. From location L3, there was the slope was unstable, but in the kinetic analysis, it was not showing any type of critical failure, neither wedge nor planar nor toppling. This is the photograph and kinetic analysis of slope L4, which was showing a wedge failure. This is the kinetic analysis of slope L5, which was showing a planar failure, as the dip direction of the beds were towards the slope dip direction, and a less also. This one is from L6. Again, it is showing a planar failure. So after that, I have done the rock mass classification as well as the slope mass classification, where for the rock mass classification, I use the rock mass rating, which is geomechanical classification of rock. And this technique is based on field and laboratory study, which involves collection of data at sites, which includes 6 parameters: the uniaxial compressive strength of intact rock, which was taken from the Smith-Hammer data; the rock quality designation, which was calculated through volumetric joint count; the joint spacing, joint condition, groundwater condition, as well as joint orientation. The first 5 parameters of this combines to give us the RMR basic, which is used in the calculation of slope mass rating as well as continuous slope mass rating. The slope mass rating is a geomechanical classification to check the stability of slopes, and it makes use of the RMR as well as the 4 parameters, which is the adjustment factors, the F1, F2, F3, and F4, where F1 gives the parallelism between joint and slope dip directions, F2 is the joint dip, and F3 is the relationship between slope and joint dip, whereas F4 is the method of the excavation. Now comes slope mass, continuous slope mass rating. This was given by Thomas, and this is the modified version of original slope mass rating, and it makes uses of continuous functions rather than discrete functions as used in slope mass rating. So when the RMR has been calculated for different slopes, rocks of different slopes, we can clearly see that only L1, L3, and L4 rocks present in those locations were of fair quality, and the rest, L2, L5, and L6, the rock present there was of poor quality. With the help of RMR basic, I have calculated the slope mass rating to classify the slopes on the basis of different parameters, which tells us that which slope is unstable and which is partially stable. So slope L1 and the slope L2 in toppling form and slope L3 in toppling form were partially stable, and the rest of the slopes were unstable, having the probability of failure as 0.6 as given by Romana in the below table. With the below table, this table was the calculation table SMR was given by Romana, where we can where he classified the rock type, stability, and failure probability on the basis of different SMR values. Then comes continuous slope mass rating. The continuous slope mass rating is kind of similar to slope mass rating, but it uses continuous functions rather than discrete functions. So it uses a finer rating values as compared to the slope mass rating. So according to continuous slope mass rating, only 2 of those slopes that were partially stable in slope mass rating, only 2 of them is partially stable now, and the rest of them are unstable, having probability of 0.6. The partially stable slopes have a probability of 0.7, probability of failure, and one slope was completely unstable, having probability of 0.9. So these slopes, the unstable and completely unstable slopes, require immediate remedial measures to be taken. So I'm not going into the remedial measures because I have some limited time. So I'll only be classifying the slopes. And in the end, I like to tell that the rock mass classifications are very significant tool for characterization of rock mass, especially for slope vulnerability assessment. The slope mass rating is most comprehensive, widely used technique for rock slope assessment. However, the continuous slope mass system seems to be more sensitive to the slope characters as it yields finer rating values as compared to the discrete slope mass system. So based on the kinematic analysis, rock mass rating, slope mass rating, and continuous slope mass rating, we can classify we can find out the type of failure that will occur in the slope, even the direction of the failure of the rock mass that will give us the direction of falling out of rocks. The rock mass rating will give us the type of rock, and slope mass rating and continuous slope mass rating will classify the slopes. And due to that, and with the help of that, only 2 slopes were found partially stable. However, the rest of the slopes were unstable, and they can fall in the presence of during monsoon season, in the presence of water, which will increase the pore pressure and hence decrease the effective stress. So this explains that geological structures, mainly the joints as well as the bed plane and even the slope dip and slope direction present in the slopes, influence the type of slope failure and also the probability of slope failure. Thank you.
Okay, thank you, Piyush. Am I audible?
Yes, sir.
Okay, so please
stop sharing.
Stop sharing.
May I ask?
Yes, any question?
Yes. Please, sir, say what kind of rocks you studied during your investigation.
So the major rock types present there were dolomitic limestone, but they were very crushed because of many fault zones present there. The major thrust zone, the slopes is present in the major thrust zone where the north lunar thrust passes through it.
Make it slow, not so rapid.
Okay, sorry.
It is the limestone is there, fractured limestone.
Yes.
Fractured limestone. Why it is fractured?
It is a fractured dolomitic limestone. Since the slopes, the location of the slopes were present in a very prominent location, and it is a thrust zone, which from where a north terminal thrust passes through.
Why it is fractured? No? Why it is fractured?
So because of thrusting, a lot of thrusting that has happened in the area. Due to north terminal, there are present a lot of numerous faults were also present in those locations. Because of limitation of time, I didn't show a lot of pictures and other data also.
Okay, Vitali, it is clear for you? Okay. So, okay, any questions more? So, once again, thank you, Piyush. Now, the Tapiwa is here.
Yes, I'm available. Good afternoon,
Okay,
sir.
so kindly conclude your of the observations within 10 minutes.
Okay, thank you very much. Let me.
And what is your topic? This is the challenges and opportunities in monitoring geohazards. It's okay?
Yes, yes, sir.
Okay, please share your view. Please share your slides.
Okay.
This is the last presentation for today. and then our team, we will close this meetings after this lectures. Okay. Our team, we
Okay,
will.
are you able to view the PowerPoint slides?
Okay.
Okay.
Okay, good afternoon, everyone. My name is Tapua Frank Pachangore Moto, and I, along with Dr. Raul Vema, will be presenting on the challenges and opportunities in monitoring geohazards. And this is the outline of my presentation. I'm going to give you a background on the problem. I'm also going to look into monitoring techniques that are being used. I'm going to look in challenges that are faced while monitoring, and also I'm going to evaluate opportunities that are present within monitoring, and I'm going to have a conclusion. So in the first instance, we are all aware that geohazards are destructive in nature and more often lead to fatalities and destruction of infrastructure. And despite the knowledge that we have over several decades for geohazards, there's still high incidence of disasters. And this can be a challenge as we are all aware that the disasters, you can have avalanches covering property and people being still present, and there being fatalities. And we are all aware that deformation takes place gradually, and in the case of slope stability, and more emphasis should be placed on monitoring as opposed to predicting, because what we are saying is that when you are having a case of slope instability, it happens over a long period of time. It's not an activity that happens instantly, and you will have those instability. So for the monitoring techniques that can be used for monitoring the geohazards, we can have leveling, we can have RTK GPS, we have static GPS, we have traversing, and we have IMSA. And I'm going to give you a detailed breakdown on all of these monitoring techniques that are being used. So if you take, for instance, leveling, you are going to use an equipment such as a dumpy level, and you are going to take that level principally for most of these techniques that I've outlined, that I'm going to explain. You are going to set them up on a tripod, and after you set up that equipment on a tripod, you are going to have a level that you are going to set up on top of that tripod, and from that level it will be having an optical telescope, and that optical telescope, you'll be taking measurements on a leveling staff, and this is relative to a leveling staff, to a benchmark. So usually you are going to have a benchmark, which is a point which is having a known elevation, and this is a low-cost method. It's used for many engineering projects and also used in the mining sector. So this is an example which is of a tripod which is used as a platform for your level, and the tripod is used for different functions. I mean, you can use it for a level, you can use it for a traverse, and you can also use it when you're employing the RTK GPS. And this is also an image which is showing a level, which is an optical instrument that is used. Then this is an example of a leveling staff. So all of the measurements that are being made, for instance, as you can see from this image, the first point that you'll be having, it will be called a benchmark. So for the benchmark, it's a point which is having a known elevation, and it's normally established by the surveyor's general office. Then all of the other measurements of all these other elevations, they are made in relative to this initial point. But what is important in this series of observations is that you are going to have you are going to repeat measurements over a certain period. For instance, you can make your repeated measurements over a period of 2 weeks or a month, and you're also going to, because these deformations, for you to be able to understand the extent and the variability of the landslides, you also need to be able to have accurate measurements. So normally for these measurements, they have to be within an accuracy. The margin of accuracy has to be less than 1 centimeter. And another technique which is used is global positioning system, or more often known as GPS. So for the GPS, it uses a constellation of satellites, and more often there will be 24 satellites which will be in orbit, and they will be taking measurements against a receiver which is on the ground. And for the most common type of GPS is the one which is shown in the image. But this type of GPS system unit it's having inconsistencies when you're making your observations, because at times you can take your measurement and the observations that you take, they will be off by, for instance, 30 meters on the vertical plane. So this type of equipment is discouraged when you are making these observations for deformations. Rather, you would use what we can call an RTK GPS, which is real-time kinematics, and these can have different constellations. You can have GPS system and also a drone. So your GPS will form as a base. It will be taking measurements on the ground. Hello? Sorry? Hello? Okay, continuing. So
Yeah,
what I'm
please
saying
continue.
is, you can have a scenario whereby you set up your base station. So your base station is an arbitrary station whereby you'll be collecting your information, and you're having what we call a rover, which will be collecting information as you move. So in some cases, you'll be having the rover being a backpack system, wherein at the end of the day, it's the entire system is going to use a principle of 3-point resection to calculate the coordinates in the terms of the y, x, and the elevation values for all of those points. So this is the initial type whereby this GPS, it will be on the base, it will be collecting information, whereas you also having a GPS system connected to your drone, and it will be also collecting information on the different elevations in space. And you're also having a system whereby you're going to have a radio connected to the GPS. So this is a highly accurate method which can be used to collect your information. And your measurements, for instance, in this case, they will be accurate within 1 centimeter. You can have rapid measurements over long distances, because normally if you are using a method such as a static GPS method, it means that as the distance between the GPS systems increases, it means that the time that you are going to take your measurements is also going to increase. But in the case of an RTK system, when you set it up, the measurements can be made instantaneous. And the black thing on that image, it's a battery, and we are also having that yellow thing on the. That yellow thing is called a controller. Then you're also having the
conclude
yes,
it.
sir.
Okay.
Sorry, sir.
Conclude it. Yeah.
Okay. Another technique that can be used is traversing, and it's made using a total station, and this is a total station. Then the last monitoring method is INSA, and this is an image which is showing INSA. It's used to complement the ground measuring methods that I have outlined in the previous slides. And the challenges that we face when we are trying to understand geohazards is that we are having assumptions that material is homogeneous, and another assumption that is made is that makes it difficult to make accurate measurements is that monitoring and predictions are done in isolation. For instance, one might collect information on geological information, but does not have any information on the actual rate of deformations that are being carried out. And there are also opportunities in development of techniques that do not assume homogeneous materials. And this can also yield better results in the monitoring and prediction of geohazards. And in conclusion, I believe that mitigation of geohazards heavily depends on developing monitoring techniques as opposed to solely relying on processes on prediction which have high degrees of uncertainties, because these predictions can either underestimate or overestimate the values that you get in the case of a factor of safety. Thank you very much. I have come to the conclusion of my presentation.
Okay, thanks, Tapiwa. So it was a very nice talk. Any questions, please? Please unshare your, stop sharing your files.
Okay.
Any questions from the audience? So, okay, I think Ramota. Yeah.
One small question.
Okay.
Okay.
Tapiwa.
Dear Sir Tapiwa Ramota, sorry. What can you say about the photogrammetry approach to solve those problems which you described in your presentation? Is it as far as I know, it is very simple, rather simple, of course, and it is very cheap, taking into account those equipment which you use for that purposes. So what do you think about that, about photogrammetry approach?
Okay, I believe photogrammetry, yes, of course, it's very cheap because you can take, for instance, satellite images, and you can have those, for instance, INSA images. You can get INSA images free from the USGS website. Those will be free, and you can make your analysis on the deformations. But you cannot use those the images in isolation. You need to back up the information using the conventional methods, because the benefit that you can have from using those like photogrammetry principles is that it's faster to collect data. For instance, for a period of maybe for more than 10 hectares, you can acquire your data more faster as compared to the conventional methods of using maybe a level or a traversing. But the accuracy is also compromised to some extent in some of the satellite images, because remember, if you're having, for instance, the digital elevation model, it's going to have an inconsistency of 30 meters in the vertical direction. And this is going to also affect your measurements for the deformations. So you have to use a combination of ground-based methods and those satellite-based images.
Okay, thank you.
So, okay, thank you to all of you. Dr. Ramotar Singh.
Yes, thanks to all, and now we will close this for tomorrow.
So for tomorrow at the same time, so we will be gathered.
We will meet
for the second day. Okay, so our team.
Yeah.
Can you?
Thank you for a great day of webinar. See you tomorrow at the same time, as you said.
Okay, see you tomorrow. Sergey has gone somewhere in the meeting. Okay,
Yeah,
please ask. Please ask to the your technician. Please close the webinar.
Yeah, of course. We will close the meeting and YouTube streaming in 5 minutes.
Okay, please ask them to close this.
Of course. Of course.
Okay.
Okay, bye.
Okay, bye. Bye.
Bye.
See you tomorrow at the same times. But please ask to the technician person to close from the system.
Yeah.
Last time it was recording 1 hour after the.
Yeah, I remember it. Yeah.
So first they will close the recording systems, then they will close the this conference. Okay, Sunita, you have several questions regarding the conference. You belongs to, now you can, okay. You know about the Sunita? Dr. Ramotar?
No, I do not know.
Introduce yourself,
Sunita. Sunita, kindly give introduction. She is not speaking yet.
Okay, sir.
But she has joined beginning and till the end.
She asked me at what time, up to what time this webinar will be ended. Syed Akif Hassan.
Hello, am I audible, sir?
Yes, you are audible.
Yes, sir.
Maybe now the webinar is finished for today. We are waiting to close the systems from the Karelia. So how was this topic listen?
It was wonderful, sir. I mean, it was really inspirational, and we learned many things. Yeah, with this.
So the mostly it is on the landslides and other hazardous, some seismic hazardous and some other. And
thanks for your webinar, sir. Thanks a lot.
Okay, so tomorrow at the 12 o'clock, 12:30.
Yes, sir. We will be there.
Okay.
Okay. Thank you, sir.
Okay,
Thank you, everyone.
Okay, we will leave this conference.
Okay, you leave. So maybe Harshita, you can also leave. So tomorrow, your lecture is tomorrow. Sunita, you may leave now, no problems. Okay, thank you.
Okay, sir. Thank you.
Thank you.
And now the Iftikhar. Who is this Iftikhar? You remember?
No.
Okay. Maybe you leave this one, Iftikhar. Are you listening us?
Dr. Draupadi Yadav is also.
Okay, so thanks to Dr. Draupadi for sharing all the photographs regarding all the lectures. Tomorrow is your lectures too. Draupadi, are you listening us?
I hope she is not listening.
Okay, not problem.
Okay, Professor Binod, we will leave this now.
Okay.
Okay.
Okay. So, but okay, leave it. What we can do? The problem is this: the system is still working, recording. Okay, Draupadi. Draupadi, you may leave also now. Iftikhar. Okay, so now you closed.
Yes, I said technical.
Okay. So.
Okay, bye. You can close too.
Okay. Draupadi, are you listening me?